Hey, hey guys. Welcome to the last penultimate week. I actually don't know. Were we planning to meet next week? That's Friday next week. I don't know. So I'm happy to meet next Friday if you guys want. But Thursday is your final. But you may have interesting things to say, and you may want to have a talk show conversation next week. Without me participating even. So let me know if you want. There is a meeting scheduled, so we'll see how it goes. Right. So if you want to meet next Friday, I'm perfectly fine with that. Okay. All right. So I'm glad to see a lot of you. Yeah. Oh, Vincent just sent me a chat message. Hang on. Yeah. That's fine. Okay. Vincent, can you hear me?
Yes, I can.
Okay, great. That's fine. No worries. And Kyle Lee also. So if you can hear me, that's okay. But try to see Kyle if you can get your video on, unless you're at work or something. Okay. So if you have any questions, I'm happy to answer them. And otherwise, you should just feel free to talk amongst yourself, trying to help each other. I know a lot of people are now very close to the finish line. Many of you are working on quest 8 or 9. 9 is likely to be more challenging than all the other quests. But like I said, if you crack 9, you're totally set up for 2B. I know that there are other sections of 2B that are being offered for fall, and they've all filled up. Only my section is not filled up. That's fine. Students always pick the easier sections. So they think about it. And are any of you guys planning to do 2B at all? You don't have to do my section, but are you guys planning to continue on to do 2B at Foothill or elsewhere? Yeah. Well, consider doing my section, especially if you've completed blue, because you will actually get credit for blue also, but it will be harder. It will be a harder section than some of the other sections that are on offer and, which students have basically snatched up. But, I think that if it's most of these easy sections, I've been in these easy sections. I don't know if students actually learn anything, they just get by. So, but if you do my 2B, you can look at the Reddit posts and people talking about what they've learned and all. Everybody says they were shit scared before they enrolled in this class, but and during the middle they thought they were going to drop, and but at the end they're saying, oh my gosh, I'm so glad I stuck with this, and I'm happy that I took the more challenging version of this class. So
I have a question. So for CS2B, I'm currently in high school right now. So would you recommend that I could take the course simultaneously along with school, or is it something that I have to dedicate my time to completely?
what are you working on in school? What is your major in school?
Oh, well, I'm in high school.
Yeah, in high school, are you in the math, physics, math track or biology track or language track? There's many tracks, right?
We don't have a specific track at our school and stuff
Oh, you
like
don't?
that.
Oh, so
No,
you
we
have to do
don't.
everything. You have to
Yeah,
do.
yeah.
All right. Well, it basically depends on how challenging you find math and physics.
Okay.
Everything else is reasonably easier, I think, in high school, because math and physics are math especially, that is what really forces you to think. Physics gives you a chance to apply what you've learned in math and see if it actually works out in real life. Okay, so those are the two most challenging ones, starting with math and then physics. If you find those two classes to be easy, meaning less than 4 or 5 hours of work a week, yeah.
Okay. Yeah. All right.
Then you should be able to manage 2B. You can also, you can just enroll and try it out because you've got cleared. If you do 2A, you're cleared to do 2B. You can enroll and try it out for the first couple of weeks. And I think if you drop before the second Friday, you get your money back or something.
Okay. Actually, it's free for us anyway. So I was just wondering.
I didn't know. How's it free for you?
It's a part of our school. It's like a dual enrollment thing. So yeah, we don't have to pay any money for it.
Well, that's really cool. Okay. Yeah, that's good. So maybe they can pay for your 2B also.
Yeah.
Yeah, you can drop in the first 2 weeks. You can drop, and it won't show up on your transcript at all.
Okay.
It'll be as though you were just. I usually discourage that because the second week is when things start getting challenging, and but then it eases off later on. So I discourage people from just enrolling in 2B and dropping after 2 weeks. But you have a fairly good sense of how 2A progressed, and then you will also know by the first couple of weeks
Mhm.
what is in store for. And also, before you drop, check the Reddit and see what other people have said about various quests,
Okay.
and
Yeah.
you should be able to
Thanks.
handle it. I know.
Mhm.
Yeah. There have been people who've done 2B along with a full course load school and been successful.
Okay.
But it all depends on how many other things you're doing. I was talking to some of my past 2C students yesterday, guiding them over through some technical, report. And I actually, it occurred to me, and that's what I told my kids too when they went to college, is a lot of students seem to go into college with a misunderstanding, which essentially will not set them up for life. In fact, it'll even, not ruin, it'll even set them up badly for life. Meaning, as the students, and correct me if I'm wrong, when you enter college, you can look around you and look at all the students, and you'll see a whole bunch of students who are just trying to get popular by getting into lots of clubs, starting a lot of clubs, and they want to get a leader tag in their resume. Say, I'm a leader, right? So I want to go to a manager position, not an individual contributor. So I'm going to start leading in school itself. So they start clubs. They become a president of a club. They do all these crazy things and help people out, but not really focus on what they're supposed to do, which is, learn. Because you're here with not here or school also, college or anywhere. It's like going to a restaurant, and a really expensive restaurant, and saying, well, I've already paid the money, but I'm not going to eat anything. I'm just going to hang around and chat with people here and go up, right? So, and all the customers in the restaurant will thank you, saying, well, you know what, I had a great meal because I was eating, and then this guy was giving me lots of jokes and all, free entertainment with food, okay? And they all go home happy with a full belly and happy. But you went home hungry, having done nothing at all. Well, except if it was made you happy to please all these other people, that's great. But you can please all these other people anytime in your life. So this is the bad time to please other people, is when you are, giving up something that you could have got and use that for benefit of everybody later on. Usually, I don't want that now because it's going to be hard anyway. I might as well do the easy things by being a president of this club, right? So a lot of students, and I think I was guilty of that when I went into college for the first couple of years. Actually, it was for my grad work, not even for my undergrad. Yeah, undergrad, I was pretty much focused, I think. But when I went to grad school, I just diluted my efforts by, belonging to many clubs and trying on leadership roles, and even not even college related. Uniform was a Unix club in the city, and I said, oh, I want to do Unix and take. So I was, took on leadership roles there. But at the end of the day, none of that really works as well as the education you get. And once you're really, really solid on the education, you can do everything else you want: leadership, public service, philanthropy, everything else you want, you can just do at your own pace, easily and comfortably. Whereas in school, you're going to be struggling to do everything at the same time, and it's not worth it. And I can also tell you, because I've when I've interviewed people for job positions, many times I get resumes that basically emphasize the leadership skills and all the different clubs and all the different initiatives the person has led. Um, and but those people, but at the cost of really technical work they've done. So I can tell you, right? Most hiring managers, when they're looking to hire anyone less than a VP level, even directors, okay? So only when you get to the VP level are people really, really concerned. Is there a solid leader? Right? And for getting to a VP level, you need a lot of experience, right? Nobody can jump right out of school or college and get to a VP. Even though you can, or you may have all the money and the power to do that, it's a bad idea to become a leader before having been under a good leader. If you become a leader without having seen how you are being led, many people fumble there, and you get fewer opportunities to be a good leader, right? You get lots of opportunities to be a good individual contributor, but fewer opportunities to be a good leader, because if you fail a few times in being a good leader, you're not getting there again. And so I think I diluted myself, and but then fortunately someone gave me knocked some good sense into me, and I said, oh, all right, only one other thing I want to do. Everything else is classwork. But I don't look at all the other frills, bells and whistles of the candidate. If I have a particular project or some job that needs to get done, I know what the skills required are. I know because the existing people on the team are working 24/7 practically. Well, typically not 24/7. They're working their butts off, but they're not able to get everything done in time because their hands are full. Everybody's working on all cylinders, focused, but they're still not able to do it. So we know that, well, if we proceed at this pace, it's going to take 2 months more, right? So that's when people decide, okay, well, this project has got a longer life. It's going to grow, so we want to bring people in. And so at that point, hiring managers already know. There's no hiring manager anywhere in the world, especially in any of the big companies, right, who say, I want to hire just because I want to grow my team. Nobody hires just to grow their team, unless there's an egomaniac out there, right, who wants lots and lots of people reporting to them and say, I'm the head of 5,000 people, right? Then, well, they're really not leading anyone at all. They're just being a manager there. And so a good manager, in fact, the managers that you want to work for, they're not looking to hire people just to grow the team or to grow the company. They are looking to hire people in order to get shit done. And so if they know what needs to get done, they already have a good idea of what that person is going to do. So when the resume comes in and they're scanning, typically they get hundreds of resumes, right? So even though they've been screened by recruiters and internal recruiters and they get to you, but even then you have a pile of them and you got to look through them. And you, in addition to all the other stuff you're doing, right? So they don't waste time looking at, okay, well, this person was a drama club leader, or the Synopsis Science Fair win a prize. Okay, well, Synopsis Science Fair win a prize, that's great, but is there any evidence of that knowledge that was got from the Intel or Synopsis Science Fair that filtered down into their physics course? So what's the point in getting a Synopsis prize for the top physics experiment when if you make a fundamental mistake in a physics experiment that you got it done, right? So the current has got to be controlled in this coil if I want to measure the magnetic field correctly, right? And then you say, well, I'm just going to do some battery. I don't even know if the battery is full or what the voltage is. I'm going to do this, right? It's a sloppy experiment. And so but someone who's done the science fair experiment properly, they would also bring that knowledge to bear, because that some mentor or guide, when they're doing this experiment for Intel, they would have told them, well, you know what, for this experiment you need to control for 7 different factors, not just 3, because you've controlled for 3, but there are 4 more factors that could put noise into the experiment, so control for those 2, right? And then we get to understand, wow, okay, there's so many things that I need to control. So last time when I did my physics lab, I got the pendulum period all wrong, right? It was supposed to be like this, it was like that, okay? So how can I control for that? And, oh, that jagged thing was because of the factors that I didn't control, and thanks to that mentor at Intel. So I'm going to come back and redo my physics experiment, and then you get a perfect curve, right? But that will also show in your grades and everything. And so the people who want to hire you will look at things that you have done in the field that show that you have actually learned the stuff, not information from some other party that says that you have mastered it. Think about it, right? So if you are the president of a club, that is not direct information of your expertise. It just is indirect information saying that that person was in a position where they could have learned a lot of things. So now you can test them for it. That's what it signals, right? So if you put these things in your resume, also make sure that you are solidly backed up on the academic side, all said and done, right? For the first 25 years of your life. The only thing you really need to bother about is sucking up as much knowledge as you can. Because for everything else, when you're dating, finding a partner, finding everything else, you got a lot of time after that. If 25 years is old, it's not like that's the end of your life. It's actually the beginning of your life. So just focus on learning, because that's the most valuable thing you're getting here. So anytime you go to a place where you have 10 different things and one of them is highly valuable and the rest of them are not so valuable, which one you pick? You go home with the most, as much as the most of the most valuable thing as you can, right? Because the rest of it you can buy anytime. And even if you don't do my class, even if you go on to some other college, you go Stanford or UC's or whatever, they're talk to your seniors, find information online, because it's also easy these days. Find out the most challenging course you can get into, right? Those are the classes you need to get into. And if you think it's too challenging, then the right thing to say at that point is, well, it's too challenging for me, I'm going to drop this class. Okay, that is what 90% of the students say. When things get too challenging, the first thing that pops in is, oh, maybe I enrolled incorrectly. Maybe this class is not for me. Okay, that is the last thing that should come into your mind. The first thing that should come into your mind when you find something challenging is, oh my gosh, okay, I just need to put more time into it. What other, useless shit am I doing that I can get out of my life so I can focus more on this? Okay, that is the first thing you should look at. And even if you don't think it's useless, this is what you'll do into a CS2B continuously, when you'll be doing it in algorithms. Because when you get to CS2B and working on algorithms, you'll find that in order to do something, there are 3 or 4 different ways, many different ways of doing the same thing. So you can actually do it. They're all useful ways. Okay, useful meaning they all get the stuff done. They all get your data structure to go into the state that you want. But then you're saying, well, even though they're all useful, I want to pick the most useful one. Meaning, I want to pick the algorithm or the technique or the programming pattern that gives me what I want with the least amount of effort from me and from the CPU. Yes. Because what's the use if you got an algorithm that will do something after having crunched the CPU and sending your fan off on a CPU fan off, all of a sudden like that. And when someone else says I can do the same thing, but it's not going to tax the CPU. The fan is not going to come on, and it's going to be easier for you because you don't have to ponder like 7 hours and chase these intricate bugs that you got to go tunneling into to find out. That's a real pain. So even though it's possible to work the solution out that way, it may be a pain. So the trick in any task, not just programming, okay, any task you're trying to learn, I think, is to figure out many different ways of doing the same thing, and also not jump into one way, but basically to draw back a little bit and say, okay, now I know at least a couple of ways to do this. Which one of these gives me the most bang for the buck? Okay, now determining bang for the buck is computer science. That is the root of computer science. Whether it is your own work or the CPU, that is what it is. So later on in CS2B and 2C, you're going to look at lots and lots of ways of doing the same thing, and you're going to say, all right, which one of these ways gives you the most bang for the buck? Meaning less of my effort, but also less of the CPU cycles. So if this does it in quadratic time, meaning it's for n equals 10, it's going to take 100 seconds. Or this does it in linear time, whereas n equals 10 is going to take 10 seconds. Okay, both of them end up doing the job, but I'm going to pick the one that does the linear time. Yes, because it's more efficient. And exactly the same logic we apply to our own lives, isn't it? Because I can solve a problem using 10 hours of programming. Well, you know what? If I think a little bit more, I can solve the same problem with 1 hour of programming. So which one will you pick? You pick the 1 hour, right? I said this to Walter and Riley yesterday. I think it's really cool. Okay, it's worth memorizing. Oh, I'm not remembering. Is that anything you can do with your mind or the computer is orders of magnitude faster than anything you can do with your grubby fingers. Okay, because electrons are so tiny compared to the nucleus of an atom that your fingers and anything that's mechanical that's made of atoms is going to take a whole lot longer, take more energy to move, right? So if someone says I'm going to keep on coding until I get the answer, right? And someone else says I'm also going to keep on coding, but I'm not going to code with my hands, I'm going to code in my head. Okay, that person who's coding in their head or actually practiced coding in their head, because coding in your head also takes a lot of practice. First time it's going to be slow. Second time it's going to be slightly faster, not noticeably faster. After maybe 500 times or 600 times of trying to do these things and saying, okay, I'm consciously not going to code it on this thing and hit run and see what's going on. Okay, I got this much of a fragment, and I think that much is okay for me to run in my head. Okay, and you try it. Well, I'm not able to run it. I'm going to try and run it in, run in my head. I'm going to try it out. Okay, that's fine. Okay, next time you say, I'm going to try it again, right? The same kind of fragment, And suddenly you'll find, okay, that science fragment I can run in my head easily. So when you find that, then even if you are a fast typist, maybe it takes you 10 seconds to type it out and test it out. But if you can run it in your head, you're done in 10 milliseconds. Yes? So what's the difference between 10 seconds and 10 milliseconds? That's 10,000 times faster or something like that. Yes? So, but you know, it's the same as when you're trying to play piano or something. The first time it'll be slow, okay? And it'll be hard, but it is important not to play slow and wrong, okay? Play correctly, but slow. Right, so because when my doctor, this is what my daughter's piano teacher told her, is that don't play fast and incorrectly, right? So and you play fast and incorrectly, it'll just set, and it's harder to get rid of the incorrectness if it's ingrained. So rather play slow but correctly according to the beat. And don't go off the play slow and then slowly speed it up. Double and 4 times the speed and so on. Then it works. And so likewise, if you start with a small fragment, you can understand that and it works. Okay, the next time you keep coming back to it, you'll see that automatically. You tell me if I'm wrong later on. Come back to the Reddit and say, you told me this, Professor, it's in the recorded YouTube video, but I tried that for the last 5 months and it's completely wrong. Totally good, okay? I'm happy for anyone to say that. So you will see that for the first week or so, this is the maximum length program I can run in my head. Okay, but record that, make a journal entry or something, right? 10 line programs I can run in my head. Okay, and if you keep going back to that again and again, you'll find that the logic gets complex, more and more complex, and the programs get bigger and bigger, but you can still run. Obviously you're not going to be able to run a 100-line or 200-line program. Not all of them. Some of them you can still run, right? Because the logic is simple. But there are some complex algorithms that, even though they're small, even take what is this? Kedane's algorithm. Kedane's algorithm. What was it for? We used to do that in class. You can Google it. Kadane. The longest possible substring or something like that. The biggest possible sum, substring sum or something like that. Okay, and it's only that much, right? In fact, John Bentley describes that algorithm in Pearls of Programming, right? It's the Pearls of Programming. John Bentley at AT&T Bell Labs, a very, very long time ago, right? He put together a very thin book, very small book, which actually has tiny programs in it, but all of those tiny programs gems, because these tiny programs will take a long time to understand and actually figure out they actually do the right thing and never do the wrong thing. Right, and so he called them pearls of programming, and it's beautiful. But some of these will obviously take a long time, and you got to work things out on paper. But still, regardless, I think it is good practice to not jump into coding and move atoms when you can move electrons. Don't move atoms when you can move electrons. Okay, and I think, in fact, when you're thinking in your mind, it's not even electrons that are moving. Right? Anyone who's done physics and electricity, they knows that electricity is not the flow of current. Okay, electricity, the electric current is not the flow of actual electrons. Okay, the electric current is actually the flow of the electric field, electromagnetic field. That is how, when you apply a voltage here, you can see that voltage as far away as the moon in 1.5 seconds. I don't know how long the light takes to go from Earth to the moon. I think it's 1.25 seconds or something like that. Yes. So if you apply a voltage here on a conducting wire, you will observe the voltage out there in the moon exactly 1.25 seconds ago and later. And how can an electron travel from here to the moon in 1/4 second or 1.25 second? That'll be faster than, I don't know, it'll be at the speed of light. Yes, but electrons can move at the speed of light. No matter can move at the speed of light. So obviously, if you can think at the speed of current, you're actually thinking at light speed. You're not thinking at electron speed even. Yes or no? Because the electrical thing that happens in your mind, it's all the flow of electrical fields. Not individual electrons will just move when the field changes. The electron will just move slowly to balance out things. Okay, and so electrons are they have inertia, electrical inertia, which gives inductance, as well as physical inertia from the mass. So they're sluggish. But the field does not have any inertia. It's like that, bam, bam, bam. Well, apparently it does have inertia. Well, maybe it does have inertia because it does take a finite amount of time to go from one place to another. But that's where I'm going for. That's where what I'm trying to say is that get into the practice of coding in your mind, and a lot of courses don't emphasize that. I'm pretty sure you can do all of these other courses at any other course in a community college or even some of the universities, right? They're happy with submitted solutions. And you can pass the class with just submitted. You can even get a good grade, a good grade with pass with flying colors. If you just have submitted solutions that you did in your own time and no direction as to or suggestion saying don't always code everything, don't jump to the computer, don't. In fact, what you should do is say, well, even though I'm living in the 21st century, I only have access to a computer 3 hours a day or 4 hours a day, right? And 1 hour a day, one of those hours is taken up by Fortnite. Okay, so I mean 25% of your time you play, right? 75% should be education. So you say, I only have access to a computer 4 hours a day. Well, I don't follow that, obviously, but I think it'll be good. Maybe you can try it out, and say, and maybe that'll force you from saying, oh, you know what, it's a really good idea. I'm so itching to try it out now. I got to go and check it out. But unfortunately, I don't have access to the computer until 6 p.m. Okay, then you're locked, isn't it? You're locked, and that way you're forced to say, well, I can't get to the computer until 6 p.m. What can I do to test this out? Okay, I'll try my best to see what happens. Okay, you're gonna force yourself to run it in your head until you get to your computer, right? And say you can't get to a place where I can't simulate anymore. Okay, and you give up. And then after half hour, you say, well, you know what, it's not 6 p.m. yet. Let me try a little bit more. Okay, then you get a little bit more in the path. And by the time you get to the computer, maybe 80% of the path has already been covered mentally. Yeah, so those are tricks you can try. I don't know if it's going to work, but those are tricks you can try. Essentially, it is just all practice in what I think is just deferment of gratification. Meaning that, if you can do something and you can get that immediately, it's, children, that's children, right? The very young children are like that. You have a piece of candy and they have to have it immediately and it's gone and they forget about it, right? However, if you don't have it immediately, you're going to think about it a bit more before you have more anticipation. And when you eat it, you'll also enjoy it for a longer time because the anticipation rises like that. And also, that the other side will be kind of symmetric. You're not going to forget about that, as quickly either. And I think it's also more worthwhile because it kind of forces people to exercise their mental muscles more. As opposed to people that are always jumping in and doing things. Okay. Once upon a time, I used to know someone who used to praise someone else, and she used to say, "Well, you know what? That person is great, and we should emulate them because you look at them, they're never idle. They're never idle any moment. They're always busy. They're always energetic. And when I was growing up, I never saw them sit idly even a second. Either they're out there trying to fix the motor, or they're trying to, cut veggies or make something, or they're always doing something and they're never idle, right? And I don't know if that's a good paradigm to follow. I think people should have this extremely valuable opportunity to not do anything at all. Right? Not do anything means not Fortnite. Okay, you can't go socialize with people. Can't go on a date. Right? You can't go to your friend's place. None of that is. Just sit down and not even reading a book or watching TV or Netflix. No, you just sit down and say, I'm just going to sit on my couch and I'm going to think about this problem. Okay, maybe you have a notebook and a pencil if you want. Right? Just think about it. And if I don't come up with a solution, that's fine. Maybe I'll think about something else. But until the clock rings, right? Set an alarm for 30 minutes. Okay. Until the alarm goes, I'm not getting up from here. So I can do whatever I want, even daydream, right? It's because that's how I practice anyway, initially. Okay. Initially I found it really, really hard to just sit down and not do anything. And for hours, right? And because after the first 10 minutes it gets really, really antsy. And say, well, and then I said, well, okay, well, it's really hard. Well, what can I do? So it's really hard to sit down, not physically do anything, and also force my mind to not wander and focus on the one thing, right? Focus on your breath or focus on the tip of your nose, and that also is really hard. And so you give up initially. So what I said was, okay, let me do one thing at a time first, right? Because I can do both, physically and mentally idle at the same time. It's hard. So let me first perfect the art of sitting physically idle for some time. So I said, for several months, I think, I was just sitting physically idle, but my mind was wandering. I would think about all kinds of shit, okay? I said everything, but I knew I can think about anything I want, but I can't get up from here. Okay, and once you master the art of just sitting down and wandering anywhere you want, but not getting up, then you can do the second stage, saying, okay, well, now I've got my physical body down to one place. Now I want to get my mental body down to the same place as well. So that is a time when you can say, well, because the physical body also creates mental cycles. So you got to get one thing down, and then you say, all right, now I'm going to try and not think about all these things, because that time you'll be much better positioned to catch yourself when you're daydreaming. Right, during the early stages, you won't be able to catch yourself when you're daydreaming. You just dream. At the end of when the alarm goes, you say, "Oh my gosh, my time is up. I was thinking about all this nonsense." Right. So, and then, but you do that repeatedly over a period of time, you will actually find that, well, you know what can I think about? Because I had these a million daydreams, but over the last month, all of them are already dreaming. Right. So you keep coming back to the same thing. You get bored of these things and say, "Okay, now what can I think about that is really fruitful and worthwhile?" And then your mind will automatically start steering towards good things when you found that all the bad things are useless. So, and I don't believe in saying that, these things are bad, you shouldn't do it. And well, unless it's dangerous to you or to someone else, I don't say that, okay? If something is not dangerous to you, not dangerous to other people, I wouldn't say it's bad at all. You should go ahead and do it. Because, if something is totally innocuous and doesn't cause harm to anyone, there is no harm. And also, from that it's not going to cause harm to you, right? You can say, "Oh, I'm going to smoke a cigarette or get boozed up tonight because it's not going to do me any harm. I'm going to get boozed up and stay at home because I'm not going to bother anyone else." Yeah, okay, but you got to be mindful and say, "Well, you know what, I can do that, but it harms me." So you got to pick out these things that don't harm other people and don't harm you also, and say, I'm gonna try doing that. I don't know how I got start talking about that, but essentially that is the practice. And I think, yeah, that's what I said. I was saying, I tell people, I don't tell people you shouldn't do that because it's bad at all. Right? I don't believe that in the first place, right? I don't. So bad things are things that harm other people wantonly, and in my opinion. So when people say, I got to try this, yeah, okay, go ahead and try it. If it's not going to be bad for you, go ahead and try it. Keep trying it any number of times, as long as you're going to get bored eventually. Because everything I know, every single thing I've tried, everything that people have told me is the greatest pleasure on earth. Okay, I've gone and tried, and after a while, I've gotten bored. I said, all right, before I go in the door, I know that's what's going to happen, right? And so after a while, you get bored of everything. So if it's not going to harm someone else, try it out. Get bored, because only when you get bored with the ordinary, you can find the extraordinary. Because otherwise, people will be stuck in the ordinary world. If you want to go to the extraordinary world, you got to get bored with the ordinary. You can't say, well, you know what, I don't want the ordinary world, I'm going to go to the extraordinary world. You'll never find the extraordinary world, because there's a lot of the ordinary world you haven't seen yet. And that's going to be taking up 10% of your cycles. And what is it that I didn't see over there, right? Maybe there's something really good there. So why shortchange yourself? You say, I'm going to try these things. And likewise, say, bring yourself together and say, I'm not going to code. I'm not going to code at all. Set yourself a goal of saying, 2 hours today, I'm not going to code at all, but I'm not going to do anything else. Maybe I can go walking, right? Go walking. In fact, my 2D student suggested that she was going to try to take up knitting again, because she used to do a lot of knitting apparently when she was younger, and she gave it up. And she said, I'm going to try knitting, because knitting is a great thing, just like going on a walk. So knitting, walking, those are okay, right? Just like sitting down, because sitting down, I think, unless you're accustomed to sitting down in one position for a long time, your joints will start aching, right? And so you can go walking. Anything that you can do mindlessly for a couple of hours is fine. So you can set an alarm on your phone and say 2 hours later, let me know, and you go walking. Okay. So when you're walking, you obviously cannot code. And for the first hour of walking, you're going to think about everything, right? You're going to think about your girlfriend, boyfriend, movies, Netflix movie, cliffhanger, in all the cliffhangers in the shows you watch. You're going to be thinking about those things. But how much can you think about those things, right? After the first hour, you're going to say, okay, well, you know what? That's started to get boring. Let me think about something else. Oh, you know what? I was looking at this interesting problem, and this is a cash that needs to be handled. What am I doing wrong? Okay. So when that thought pops into your head, automatically when you're doing something else, when you're walking or doing some automated cooking. You know, when you go into the kitchen and do some cook, you know, do make a dish. Again, we got to make sure we make a routine dish, right? We can't say I'm going to follow a brand new recipe today, right? I'm going to make this a marvelous new pizza I've never made, and that way your mind is engaged. You got to do things that are repetitive and you've done a million times already, so that your body can be an autopilot and then your mind can wander. So so when you get to that place, you'll find that, you know, computer science is actually greatly pleasurable, because what you'll find is that it is an incredible source of entertainment which does not require anything else other than your mind, because you can just do it. And when you get to a fine point saying, okay, now I've narrowed it all down in my mind, now if all I need to do is just test the final thing, and I'm pretty sure it's going to work, I'll go and test it out. That way you'll be able to see, you know, and that way your bugs will also be easier to find. The bugs will also be easier to find. And rather than shooting in the dark. And then same with physics experiments, right? So imagine how difficult an experiment it is to test Einstein's theory of you know, general relativity, because there's no way you can test if light bends in any normal situation, right? You actually need to figure out, well, you know what, I can do this if there's a star that is, you know, close to the sun at the time of the eclipse, and then I can see the position of the star here, but in the, you know, usually at night, but during eclipse, the star appears to be here, not here, here. And the only explanation for that is that the light that came from here bent around the sun. Okay, so that is an experiment, came out of a prediction. Now, that prediction wasn't done by doing, you know, a million sun experiments and then saying, okay, that's how I get it. No, they say, well, you know, I think about it and a long time and say, well, one way to test it would be this, okay? And then you take a great deal of effort in setting up the experiment, because that's $1 million experiment. You don't want to just do it off the fly like that. So you're going to run it in your head, $1 million experiment, and you say, okay, before the experiment is run, most of the physicists already know what's going to happen. Yes, because you're not going to set up $1 million experiment and say, well, I don't know, 50% chance, toss a coin whether it's going to work or not. No, a good physicist will only run an experiment when they have above a 90% chance that it's going to succeed, not 50%. 50% means you're still in mental realm. Okay, so in your mind, you have to keep polishing it off until you get to 10% chance of failure. And 10% chance of failure, that's when you jump to coding. 10% chance of failure, that when you move atoms, right? So you move atoms at 10% chance of failure. You move electromagnetic fields until you get to 10% chance of failure. Okay, I think that's a good you know, encapsulated form of saying that. So anyway, that's my 2 cents. I hope to see all of you. Okay, I hope to see every one of you, regardless of whether you're in school or college, or you're already working a professional. It doesn't matter. East Coast or West Coast, Vincent, right? So I want to see all of you in my 2B. Not because, you know, my numbers in 2B are flagging, and, you know, because if it's less than 20 students, there's a class will get canceled. So nobody will get to do it. But that's not the reason I want more students, right? I want more students because, you know, I don't care, because if the class gets canceled, I'll offer it again next quarter. And, you know, because I'm planning to offer all 3 courses, A, B, and C, every quarter for the next 2 years, right? So I'm planning to retire at the end of 2 years. So every course will be offered for the next 2 years. So take them inside of that window, because I think it'll be useful and helpful. And hopefully, you know, when you're done 2C, hopefully you will have enough excitement about these things that we can even do a project together, right? Because I have a lot of these projects come up from time to time. I can, after 2C, if yeah, I can use you as an intern, for example, right? So in nonlinear media to do something, or maybe even take you know, I have some ideas for how to extend questing itself. So maybe more quests, also changing some of the questing mechanics. Also, I want to change the first 5 quests of 2A. Right, first 5 quests of 2A, I'm not really happy with it because it's standard output and C out, and I have to use SDiff to compare the left and right. Yeah, for a long time I've been wanting to change that, so I can use an intern for that kind of thing. There's Unreal development, something in music. So there's so many projects. I have a lot of these projects that if you're interested in, we could work on. But first, you have to get through to 2C, finish 2C. All right. So anyway, every time I'm just taking up a lot of time. All right. So I don't want to take up any more of your time. So you should just feel free to talk amongst each other, like as usual.
Professor,
In
I have
fact,
a question.
Mhm.
I was wondering, like the Quest website you make, like, may I ask what language framework that you use to make that website?
Oh, you mean how I made how I created that? It's
Yeah.
the question website. It's actually very simple. Okay, it's but the thing is, um, it uses different languages and different paradigms of different parts. So once you know all the different parts, you just put them together. So the coding part of it and the testing and compiling and everything, that's obviously C++, right? Because you're learning C++. Now I got it. So, but then there's the UI part, the UI where you have to drop files and there's the graph and the pictures and all that I had to do in JavaScript. And again, when you use all these other languages, when you get good at these languages, you'll find that you'll be less dependent on outside packages, right? So even when you're developing JavaScript, there's so many packages out there, right? So there's, I don't know, Google has these a bunch of packages, Java, Node, even there's UI packages like Flutter, I think someone said, so all these things. But if you use these packages, you will become beholden to them. You're dependent on them, right? Because they may change, even though you may use a frozen snapshot v.3, who knows, right? So, but by learning these languages really solidly, you don't need any of these packages. You can do everything in native JavaScript. So 90% of the UI is just done in native JavaScript. I didn't use any of the packages, right? Just JavaScript code, because it's all very simple at the end of the day. So that is the UI, and this is the C++. And then in the back end, do I actually have a Lambda? Maybe I have a couple of Lambdas in Python, because the backend is all done in AWS Cloud. It could have been done in Azure or Google also equally well, but it's done in AWS Cloud. So for AWS Cloud, you can do some things really efficiently by using Lambdas. Lambdas are functions you write in Python, which you can get executed in the cloud without having a computer for it. Meaning that Amazon has set things up so that you have a Python program to run, and it'll take, let's say, 10 milliseconds to run. Amazon has all of these guys, right? All of the cloud people. They've got things set up in the backend such that if you have a program that takes 10 milliseconds to run, I can rent you a computer for 10 milliseconds. How cool is that? Okay, so you don't have to rent a computer for the whole month. You can rent a computer for 10 milliseconds, run the program, and it'll go. Right? That is a Lambda. And you can write these programs in Lambda. And I think I also use some PHP. But you know what? All of that, I for a long time, I've been meaning to re-engineer, because in the process of doing things, you learn some new things, and Amazon also comes up with new. Because when I did this, I don't think Amazon had Docker containers or Amazon containers. But I was using containers, and I had to build containers and fire them up, and do this crazy things. And when Amazon themselves have these containers now, you can just register the container and use them. So I don't need everything simplified. So I want to, at some point, I want to use a container for everything, so that I don't even have a questing server. Right now, I have a questing server, which essentially is a container because it's really thin, and it's fired off by a load balancer and taken offline by a load balancer too. So it's almost like a container, but I'd like it to make a pure container out of it at some point. So those are things that I would do. So yeah, I'm using containers, clouds, Python, PHP, JavaScript, and C++. That's the only thing. So no magic there. I think
Thank
that's all.
you.
Yeah.
I have another question. What do you personally think is the best C++ jobs out there?
C++ jobs?
Yeah.
I know. Any job in C++ where you get to do something that you're interested in is the best job for you. For example, if you are interested in game development, right, which many people are, especially your age, many of you, how many of you don't know about Fortnite? Everybody knows Fortnite, right? Raise your hand if you don't know Fortnite. So, all right, so everybody knows Fortnite. Everybody's played Fortnite. This is such a fantastic game. So if you're interested in creating Fortnite, right, creating something like Fortnite, that would be a dream job for you, wouldn't it? Okay, now with C++, that is just one step away. Because once you're really solid with C++ until 2C level, right? You need to get really solid in data structures, 2C level C++. After that, you can just master Unreal in a month using just the tutorials they give you. Unreal has like they have this. I'm pretty sure Unity and all these other people do too, right? Unreal has this thing called Unreal University, like Apple University and Amazon University. Unreal has Unreal University, so and it's free, 100% free. So you can go to Unreal University and they have like a ton of videos, YouTube videos saying, oh, this is how you do this is how you do this, right? Just like YouTube Khan Academy. And in fact, you don't even need to look at all these videos. You just need to look at the first series, getting started with Unreal, and everything else will just naturally come to you. Because everything else is just C++. Once you know how to do things the C++ way, you'll also get to learn implicitly how to do things the object-oriented way, right? And once you're comfortable doing things the object-oriented way, Unreal Blueprints is just a visual representation of objects. So in Unreal, you can build most of your game, 90% of it, not 100%, 90% of your game, or maybe 50%, depending on the logic and all, right? Just using pictures and boxes, like flowchart. So you can say, you know what, here, if a bullet is fired from that gun, and there's a balloon axe here or something like that, and you can draw arrows saying, well, is there a collision path or things like that. So you can draw arrows and say, all right, if there's a collision, then you go here. Everything can be done pictorially, and then Unreal will turn that into C++. So where expert C++ programmers shine there is that they will do less in the blueprint and more in the C++ code. Because the C++ code is obviously, right? Obviously, you're getting one level closer. You can do more. Blueprints, you can do most of it, but still there are some things you can do in C++ you can't do in blueprints, the visual. So, so once you are really good in C++, you'll try and do as much in C++ as possible, but only do the really good things that are needed to be done in Blueprint. You'll do only that in the Blueprint. So I've seen lots of projects, even Unreal projects. Some of them look really good, and some of them are even tutorial projects saying, oh, some guy on YouTube said, I'm going to create this with Unreal, and they'll do the whole thing in Blueprint. And you see that and say, why is the person doing the whole thing in Blueprint? This part should not be done with a Blueprint. This should be done because when you do the whole thing in Blueprint, your diagram gets so complicated, too many lines crossing over. It's a real mess, isn't it? But the reason I think is that person mastered Unreal, or I shouldn't say mastered, learned Unreal without learning C++. They tried to do everything in Blueprint because they don't know C++. But once you know C++, you'll know, right? This is what needs to get done in C++. That's what needs to get done in Blueprint. And so you'll be able to marry the two more effectively. So that would be a perfect job for someone who's interested in game development in C++. Suppose you want to do machine learning, for example. Right. If you want to do machine learning, you got to be careful. Data engineering and machine learning, C++, it's good to know C++, but you can do a whole lot of machine learning and data engineering without C++ using Python. Because Python is so big now, it has libraries for almost every single thing. Yeah, so you can just maybe it even comes prepackaged, most of the Python installations. They'll have a library for doing some machine learning task, all right? And in your Python, you will basically just have to get the data together, because that is what Python is really good at. All the scripting languages, Python, Perl, PHP, they're all really good at massaging ASCII data, not even binary data, ASCII data. Getting ASCII data into shape. What do I mean by ASCII data? By ASCII data, I mean data that you collect from your programs when you print cout, right? Log, that's the log line. So, when you in your computer, if you look at the system log, it's just rolling all the time, saying, oh, connection attempt from this IP address, cache flushed, it's all kinds of millions of different messages rolling all the time. That's what the system is doing. Yes, there's a log, and they come in English ASCII, because humans are going to be looking at the log file. They need to know what the system is doing, right? So it's all in English. Now, 99% of data engineering that I know, even machine learning when it comes to speech recognition and all that stuff that I've done, is a lot of the work is basically done in taking the ASCII data and transforming it into a form that the C++ can actually handle it efficiently. So when you go to do machine learning in Python, 99% of the people who are saying, I do machine learning in Python, well, what they're doing is essentially taking the data and filtering out the parts of the data that are not going to be useful for machine learning, which itself takes a lot of genius, right? Because identifying what needs to be extracted from the data is actually a great deal of machine learning. So machine learning programmers who say, give me the right data, I can give you the right insight, they're not machine learning programmers at all. A good machine learning programmer will say, give me shitty data, I'll give you the right insight. Yes? because they can look at the whole world, and the whole world is basically unstructured, right? Everything out there, but you want to look at the whole world that's unstructured and pull out structure from it. That is the essence of science too, isn't it? We look at repeating things and say, what is a pattern? What is a pattern? I want to extract the pattern from this apple that's always falling to the ground. And so that's science, and that is machine learning. But but is it machine learning or is it science for someone to say, I'm going to drop 5,000 apples from different heights and actually record the times and give it to this person who will come up with a theory? Who is doing science? Is the person performing the experiment by dropping the apples and recording the times? Is that the person doing science? Or is the person looking at all the data and saying, well, okay, there's got to be a GMM over R squared ratio here? Is that person doing science? Which person is doing science?
The second one.
The second one, yes. So machine learning and data engineering, a lot of people out there say, I'm doing machine learning, I'm doing data engineering. Really, if you go to poke some holes under, look at what they're doing, they're really not doing data engineering, right? And most of the people don't know data engineering. So when they say, I'm a machine learning guy, I'm a data engineering guy, oh, wow, that's really great, man, right? So they say, because they don't know what they're doing. When they just have to take the word for it. But someone who actually knows the material will say, oh, all right, yeah, you're doing machine learning. What are you doing? Okay, well, data engineering, what are you trying to do? And then that person will say, that person now will have to say, well, you know what, in order to do this, I'm actually taking 15,000 different log files from these exabytes of data, and I'm pulling out this information and then passing it along to this Python library. Okay, then all right, the machine learning is in the Python library, not in the code that is filtering the data. However, having said that, filtering the data is actually a hugely intellectual task, right? It shouldn't be denigrated, because machine learning and data engineering, if someone says, I'm a machine learning person, but I focus on the data side of things, okay, they actually know what they're doing. Because they say, because data engineering is a really hard task. You need just trying to find out what is interesting. Like I said, lots of things fall, but trying to figure out how to control for it. All apples should be dropped from the same height and the same, gravitational acceleration. So figuring out that's what needs to get done is part of the data engineer's job. So they need to know also. So you need to bring a lot of knowledge to bear on data engineering. But where people go wrong is saying, well, that is what machine learning is. No, that's not machine learning. So you can have a lot of a fulfilling career as a machine learning person if you're actually working on the machine learning part, which is actually dealing with, kernel functions, support vector machines, deep nets, or even trying to figure out, well, this particular massive deep net with 10 billion nodes is coming to wrong conclusions, right? So what could it possibly be in the data that I sent that's giving it the wrong conclusions? Trying to figure it out. That's all machine learning. So that's all interesting. And in order to find out, you'll be writing C++ programs or Python programs or whatever, right? So you'll be trying many cases like that. So that will be hugely fulfilling. But the most important thing to answer Pink's question is to say, I have C++, what would be a good job for me to do? Essentially, you just need to be rephrased, saying, what would be a good job for me to do? I have C++ if I need it. So, right? So then you can find the job you need, and then maybe 90% of the time, C++ will help you do it. If not, learn the skills for that job, right? So if you go into machine learning, forget about C++ for now, because once you've done CS2C, you're good. And Python will be super duper easy for you. Any other language will be super duper easy once you master C++, right? So forget about C++, but you shouldn't forget about C++ halfway, like after 2B or something, right? Do it proper, bolt down all the essentials after 2C, quest 9, right? That time, you should take the liberty of forgetting about C++ for a year and saying, well, now I want to do machine learning, and let me not even think about C++ now. Let me do what everybody else is doing in machine learning, which is using Python. Because a lot of machine learning algorithms can also be coded in Python, right? But some of the hardcore stuff needs to be done in C++. But a whole lot of data engineering also needs to happen by the machine learning engineer. So you'll end up learning Python much better because you know C++. Now you have two tools at your disposal. Now you can go to one other thing. Say, well, Python does this. Okay, well, I don't like Django, but I like PHP. So let me pick up PHP to do this, right? So it's three things, and you can build a better product with three things. And say, okay, I've got all of the backend working now, but I got the results. I need to show it to the user. But the user, users are ordinary human beings, so they can't they can decipher tables and tabular data or numbers. So I need to transform the data into some pictorial representation that will make more sense to humans. Yeah. So then you say, well, what can I do to turn the data into a picture? I need to visualize the data. So what can I do? So JavaScript lets me do that, because JavaScript gives me a canvas where I can address individual pixels in a browser. So you can say, well, okay, now I'm going to take the results from the backend sent to the browser via a Python interface in the backend over Ajax to my JavaScript running in the browser. And the JavaScript has got the data now. All it needs to do is just stuff it into an internal data structure and then show it on screen on a canvas. Essentially, that's all I do in questing. All right, that's the entire life cycle. You type the code, submit it, it goes there, it gets mushed up, and results are generated. Everything happens in a container, right? So lots of people are trying to hack into the questing system all the time, and I look at the logs. But many of them don't know that there is no questing system essentially, right? Essentially, you come in, but once you come in, you're basically taken and put into a completely isolated sandbox, right? So nothing can happen there. And there's only one way in and one way out. So into the box, it's into the questing system. So lots of people think, oh, everything happens here. No, you come in here and you take it and sent off to this unknown location in Siberia, right? And then you come back after 10 years, and then the results are taken and sent back to the user. Say, hey, there's some really cool stuff happened in Siberia. All right. So that's what happens. And so you can build these systems that are insulated, modular, so that people can hack in, and also powerful, because each one does only one thing. It can do it really well. And so that's what I would suggest. Yeah, go all the way, Ping, right? Don't stop after 2A. Do the 2B my section and 2C also. And in 2C, don't wait until the class starts to start questioning. Okay, that's a mistake that a lot of 2B and 2C students do. 2A is okay. 2B and 2C, I don't know. Students who wait until class starts to start questioning, they usually tend to not do as well as the students who say, you know what, in order to do 2B, I already need to have completed 2A blue quests. And I give all my 2B students 1 week time, and the first week for doing 2A blue quests. So even the students who come directly into my 2B, they get 1 week to do the blue quests. Now, the mistake that many of my 2A students did, or actually 2B students did when they went to 2C, right? In 2C, I gave my students 1 week to complete both blue and green. So, but a lot of my 2B students who went to 2C made the mistake of saying, well, I got this 1 week freebie now, because the quests don't start until, the quest 1 doesn't start until week 2. Week 1, everybody's working on blue and green. So I can take it easy and play Fortnite, right? That is a bad mistake, because don't wait, just start doing, right? If you got a free week, aim to have the free week at the end, not at the beginning. So you say, I'm going to play Fortnite in week 12, not in week 1. And, and that way, I think, do all of the quests, participate in the forums, get to the bottom, try to ace all of the quests, not immediately, pop all the quests, come back and ace the quests. And after that, you'll find that a lot of things just become easy for you. You see people out there thinking, computer science is hard. How many people have you met, right? People say, when you tell them you're doing computer science, they say, oh my gosh, it's really hard. Do math, oh, that's hard, right? So lots of people have that opinion, and that's incorrect, totally incorrect, because these are the easiest things to do. Everything else is hard. Everything where you have to train your atoms, everything that you have to train your physical muscles, I think is harder. Maybe for me, as I'm getting older. For you, maybe physical muscles are also easier, right? At a young age. But as you get older, moving muscles is harder than moving your mind. So so I would say just finish everything, pop it, go back, ace all the quests, get really solid, and after that, things will just become easy for you. And all these other people who say, oh, it's hard, you say, oh, it's actually easy, and do it and show them how to do it easily, and they'll actually appreciate you for that too. And things will become easy if you master C++. Okay, I know, because I have had students who got A+ in in Python and Java. Okay, 3A, 3B, 3C. They got A+, and they came into C++ and they floundered. Why would they do that? Why would someone who got an A+ in Python at Foothill, right, in a Python track or a Java track, subsequently saying, I want to master all 3 languages, so I'm going to do C++ before I go on to graduate school or something else? They do that, and they struggle in C++. And they said, and then you can even look at, Rate My Professor or Reddit even, and lots of students complain, saying, well, you know what? I was a top student in my school. I got A+ all the way. I was straight A. And I did Python. I got A all the way. I did Java. I got A all the way. But I did C++, and I'm struggling here, right? So something is wrong with the class, right? But people should reflect there and say, is something wrong with the class, or is something wrong with the way that I actually learned all those other courses? So, so I think that is the insight that should be foremost in a student's mind. Is essentially just once you that's why, yeah, once you do. Also, I think maybe they're floundering in C++ because C++ is harder apparently than the other classes. But if you, I think if you master C++ and know exactly where the memory is and how memory is being allocated and deallocated, every other language will be a piece of cake. Unless, if you go for a completely paradigm change. All other languages are procedural, right? Even Go and all these, the procedural languages, piece of cake. But you may at some point want to learn a functional language like Lisp or Prolog or Haskell. Yeah, the paradigm is different there. So there, it's not just learning new syntax. You got to learn a different way of thinking. Maybe in Prolog, it's a different way of thinking. Not hard. It's just a different way. It's just something that you weren't used to before, right? But if you mastered this that way, if you say, well, you know what, I'm not going to go there thinking it's going to be hard. It's actually easy because I did the hardest possible thing already. It's going to be easy. You go there with a mindset saying it's going to be easy, you'll find it's easy. And then you'll say, oh, wow, that's another way of thinking, a declarative way of solving a problem. This is a procedural way of solving a problem. So it's two different ways. Now you have two different ways of attacking the problem too. So then as you get older and older, what will happen is that you'll just have a lot of solutions in your inventory. Not solutions just to computational problems. If you have the same approach to life, as you get older and older, you'll just have a lot of stock solutions in your mind. So whenever you come across a problem, you'll be able to say, well, you know what, that problem, I can try this solution. That worked in this kind of social situation before. I can try that and see if it works, right? Instead of getting all worked up and personal and defensive, you'll be able to be cool and approach it calmly and say, well, that is a problem. We can see it's a problem. How can we fix that? 10 years ago, I had a similar problem and that worked. Let me see if I can bring about a similar situation here. Okay, that kind of attitude will not even flower in your mind when you're panicking. And so by getting really good in C++ or any of these languages, any language actually, but getting to the bottom. But the reason I push C++ as opposed to other languages, because Eileen, actually my 2D student, pointed out that, she has a mentor who said, doesn't matter which language, just master language all the way, proper, 2 years, and then you're good. That is the correct thing. But why do I say C++? Is because in all the other languages, you can stop short of mastering the language under the misguided belief that you've already mastered it. Okay, Python, Java, JavaScript, you can do a lot of stuff without mastering, which means that you're still beholden to a real computer scientist to come up with some really kick-ass stuff, but you'll be happily able to do anything that someone gives you to do. So there are lots of people out there saying, I'm a competent Python programmer. I'm a competent Java programmer because, give me a task, I can do it. But they're not computer scientists. They can come up with an idea of their own and implement it, from scratch in an efficient way. So that's the difference between being just proficient at it and expert at it. And so the reason why I think C++ is better to learn than these other languages is that the hard part in these other languages is at the end. And what Eileen's mentor said is, you have to go all the way. You have to master the language, get really well at it. You have to get past the hard part in the language. Yeah. But in other languages, it is much easier and the temptation is higher because people will start paying you, right? Once you get to a certain level of proficiency in Python and Java, you can get a decent job, right? People will pay you. And once people start paying you, many people are screwed at that point. Because, when they say, I got money, I got a house, I got a wife, I got kids, I got everything. Now I don't need anything more. I don't need to learn anything new. Yeah, because I can live out the rest of my life and collect my retirement at the end. That attitude will set in for most people because they've got something that works. But C++ says you're not going to get anything that works until you finish the hard part, because the hard part is loaded up front, and the easy part comes later. So so to get really good at a language, you can either learn C++, which will not let you think that you're good until you're really good, Or you can do these other languages, which may, falsely tell you that you're good before you're really good. So if you're really solid and or you have some, experienced person at home, already a programmer, who can tell you whether you know stuff or not, then you can learn Java, Python, anything else, because that person will tell you. I'll say, well, you know what? All right, you can do all these things, but you still don't know this. Then you'll be able. But if you don't know anything and this is your first language, then I think C++ is the best thing to do, because it will actually give you a really good grounding and not make you improperly believe something that is not likely to help you later on. It is going to help you. I don't know. That was a long-winded answer to your question, Peng. Was it useful?
Yeah, that's the reason I picked C++ too. I learned JavaScript first, and then I feel like it's more abstract. A lot of things they don't show you, but in C++, they show you a lot of things behind, and that's the reason I like it too. Yeah.
JavaScript ultimately is meant for the UI, right? It was born in the browser. It was born for the browser. Although there's all these people who do Node.js. JavaScript is also a server-side language now. I don't know. I never used JavaScript on the server side. Even Python, even Amazon and all these other places, you can write lambdas in JavaScript using Node.js. But I only use it for UI stuff. I don't do JavaScript for server side. Server side, here you need to learn Python at some point. Okay, you definitely need to learn Python because it's a scripting language. With C++, it's got to go to the compilation step and get to the run it. Python, it's really cool, like Perl, because you can write it and run it right there. In fact, you can just fire up the interpreter and type in your Python statement on the 3 greater than signs and have it run right there. Yes. And so it'll be good because when you write C++ programs, there's lots of little things you need to do for which you may write Python scripts. And so it is a useful thing to have. But my recommendation is for C++. So if you're really bored and you do want to learn Java also, you can also do my yellow quests. I think it's also on the question side, because I used to offer 1A also in the distant past, the Java track. And so when I put the question system together, I also did the Java quests for 1A. So it's yellow. It's red, blue, green, and then that's yellow. But you don't need it really. Anyone who's doing C++, you don't need it. Anything else?
Yeah, so I have a quick question. Like, I'm planning on doing B probably next summer because I don't think I'll have time during school.
No worries, yeah.
Could I like continue doing the
Totally,
B course for
yes,
fun
you should.
and just like not put a student ID?
Totally.
Okay. Cool.
You don't have to use your student ID, but use your student ID doesn't matter because
Oh, okay.
Doesn't matter because if you use your student ID or you use some other ID, you say Kailas or something like that.
Yeah.
So that you can go to the /q site and you can also see everything.
Okay, I'll just continue using my student ID then.
Yeah.
Thank you.
And 2A, 2B, yeah, finish all of the quests. Finish all of the quests. Keep on going as much as you can. And since you're doing it at your own pace, you may be tempted to ace each quest before moving on.
Yeah.
Because during the quarter, I actually tell students don't ace. Move after you get the password and come back and ace it. But when you're doing it on your own, you will feel very tempted to ace everything. So you just have to be on your guard. Saying after the password, move on. And the reason I say that is because a bug you're trying to fix to ace a quest will actually automatically become obvious to you after quest number 7 or 8. When you've solved a later quest and you look at your previous quest and you say, I didn't pass that one, you automatically know, oh, that's why I didn't pass it. You don't have to do any experimentation there. So does that make sense? So as you solve the later quests, some of the easier, the earlier quests will become easier for you. And so you won't have to bang your head on a wall. So yeah, that's the temptation to overcome. Don't try to eke out every single trophy, but at the same time, you do need to get every trophy, right? After you complete a level, 2B, right? When you get to 2B9, you should not go on to 2C1 until you say, okay, I've done 2B9, now I'm going to go back to 2B1 and make sure I get every single trophy. or at least a maximum known, right? Because I don't know anyone knows what the maximum number is. Even I don't know what the maximum of trophies is, because at some point I started adding trophies and I stopped keeping count. So I don't know what the max number of trophies is. And so, but students, some of the students post these things in the Reddit saying, well, this is a chart for each quest, this many trophies, right? But I don't know if they're correct, but certainly that's something the students are shooting for. Anything else?
Yeah, I've got a couple questions for you, Professor.
Sure, yeah, go ahead, Kyle.
Yeah, so you may have heard this before, but a lot of the universities and colleges right now seem to be really expanding their CS programs. And while demand for CS people might be going up, it's pretty clear that the job market's going to be really flooded with a lot of CS people in the near future. So aside from grades and kind of the standard stuff, how might you recommend that someone pursuing CS make themselves actually stand out?
Great, fantastic question. Okay, and especially in light of what you just said, there are so many universities out there. Everybody is emphasizing CS and increasing the class size too, right? It's Georgia Tech. Someone told me basically takes anyone who comes in, but they're not going to reduce the standard of instruction, saying that we'll take in 1 million students, but only 10 of those guys will eventually pass anyway. Just make sure you know that. Okay, so I don't think the standard of instruction changes at any of these institutions. They're just getting more money by saying, well, if you want to give us your money, come and give it, right? Even if you don't know CS, we'll take you, right? And so what will make you stand out is to make the decision right now, saying that, okay, since 1 million people are going to be doing CS, I know for sure that grades are going to be worthless in 2 years. Okay, nobody's going to look at grades because everybody, if 1 million people are doing CS, someone will figure out, right? There'll be some kind of a, Kumon Institute or something that says, how do you get A+ in all these kind of classes, okay? And they'll teach you exactly what needs to get done. And people will just get massive grades without really learning anything. Because everything is a trick, isn't it? Once people figure out that grades matter, there will be enormous amounts of energy invested into how to maximize it, right? Once you figure out there's, you pick a couple of, gold nuggets in some area, immediately a prospector will say, all right, there's lots of gold nuggets here. I'm going to try and max out and say, how can I get the most number of gold nuggets out of here? They'll come up with all kinds of crazy schemes. They'll say, I can use a drone here to do this. All kinds of crazy things, schemes will come up, which you never even imagined, to say this is how you can maximize the gold output from here. So grades have turned out to be like gold in the last few years, right? So, and people out there seem to be getting employed based on grades and not based on their expertise. However, those people who are getting higher on grades, they're also getting fired. That fact is not being, that fact is not out there, right? Even the statistics from the government, they say how many people got employed. They don't say how many people got fired. So what happens is that this is a quickie. People who get good grades by hook or crook, not really mastering the material, they go into their some university or some company saying, well, I came from this top-notch university and I got A+, so I need a job. But once they go in there, people are not going to, your colleagues and your manager, they're not going to say, cut the guy some slack because they came from Stanford or Harvard. They're not going to do that, right? They're going to say, everybody who comes in here is held to the same standard. Everybody has to do the same work. So if someone comes from a top-notch university with all A+, they're not able to pull their weight, they're going to get fired. They're not going to say, well, we need a lot of these elite graduates in our company to raise a profile. Who's going to pay? Will anyone pay $100,000 a year or $200,000 a year just to increase the company profile? No, right? You can get much better by just marketing. So getting elite people to work for you and paying them a huge salary just to up the profile of the company is a bad idea from the company's perspective. You should never go to a company that that is trying to do that because that is a bad company anyway. So you should only go to a company where no matter where you come from, same standard. And that way, don't focus on the grades. Right now, make the decision saying, I'm not in college for grades. I'm in college to basically suck up the most interesting ice cream and desserts out here, right? And the most valuable, the most tasty and the most expensive maybe, right? That's what I want. I don't want any of the fluff. and I don't want to waste my time when I'm in college going out on these pointless parties, going and spending a night in a bar, getting drunk, and a couple of days gone because of my hangover. All of that is total nonsense. That's time wasted. Gold you're throwing out the window, because this is a time when your mind is also most equipped to it's like a sponge, right? It's sucking in everything out there. And if you are saying, well, I got a sponge here, I'm going to load it up with dirty water, right? It's going to be filled with dirty water. And you think it's full, but it's full of dirty water. However, you say, I don't want dirty water, then the sponge has got no chance except to fill up with clean water. And so when you're in an institution that is imparting education, anywhere that's imparting education that is valuable, you should essentially deprioritize every other thing in your life except food and water. Okay, so stay alive and learn until you don't want to learn anymore, and then you can do anything else in the world, right? So you say, I know everything, now I can go flying to Mars. All right, so I think that would be the better strategy and approach. Don't focus on the grades at all. Just focus on learning, and that way, when there's 5 different, 5,000 different A pluses out there who've been churned out by these colleges that are taking in CS students by the hordes, right? You'll be able to say, well, even though there's 5,000 different people, there's these problems I can solve on a whiteboard. Those people can't. So when you go to an interview, they're not going to say, well, you got an A plus, so you got a job. No, they're going to say, well, you got an A plus, this problem will be easy for you to solve, right? So they'll say, A plus people go directly to this problem and solve it, right? If you're not an A plus person, you'll struggle there, and not a real A plus person. Yeah. So if you just focus on the material and don't care about the grades or the college or where you go, even if it's YouTube University, if you go to YouTube and watch videos, and if you just apply yourself, you'll just stand out automatically. Right? People don't stand out because of grades. Think about it. Even if you stand out because of grades, how many years of your life do you think you're going to stand out because of your grades or a college or an institution you went to? How many years? 2 or 3 years? I don't know.
Maybe a few
After
months.
10 years, yeah, maybe 2 months even, right?
Yeah.
After 10 years of working out there, nobody is ever going to ask you, where did you go to college and what your grades were? Yes. So if you're 20 years old now, right? After you're 30, nobody's going to ask you where you went to college and what your grades were. So if you're preparing to look good in your 10 years, 20 to 30, you're not going to look good for 30 to 100 or 30 to 200. So prepare to look good when you're 30 and over. Then you won't look and say, I'm compromise on this. I don't care. I don't care what people are going to think about me for the next 10 years, right? I don't care if people think that I'm not social or I'm not a leader because I refuse to pick up this group or club that is going to dissolve if I don't help it out by being the president. No, I don't care. Right? If you're going to call me not a leader, that's fine. Okay, because right now I'm not trying to be a leader. I'm trying to learn how to serve a leader, because once I know how to serve a good leader, then I'll know what to expect when I become a leader. Because people who don't know how to expect good work to be delivered to them, or how to make good work, right? So here's what I think, right? There are no leaders. You can only get followers. You cannot ask people to lead. You cannot ask people to follow you. People have to follow you willingly. So anyone who says, follow me because I'm a leader, do what I say because I'm a manager, director, VP, right? They're not VPs. They're all, incompetent people. A real VP, a real CEO will not tell anyone to do anything. They will all go to the CEO and say, well, we want to do this. We want to do this. We want to do this. Can you help us? And so being a master will put you in that situation, saying that, I'm not going to go and tell people to do things. I'm just going to do things really well so that people want to do things like me. And they'll come and ask me and say, I want to follow you because I want to do this. I want to do the same thing you did, so I can follow you, right? So that is the way to become a leader eventually, not by chairing these clubs and companies and little things. And also, you can, when you form your resume in a couple of years or whenever it is, you can keep that in mind and de-emphasize all those things early on. When you're going for individual contributor jobs, I've seen resumes that come in saying, I was a leader of this club, I was a leader. Don't do that. Okay. When I see that, I actually put the resume away because really, I've done that in the past, right? I have explicitly taken conscious decisions to say, if I have two competing resumes and one of them emphasizes leadership skills and the other one doesn't, and it is for a job that I need to get done, which doesn't require leadership skills, I'm not going to hire this person. Because if you hire a person who wants to be a leader in a non-leadership role, the company is doomed. Because that person won't do their job. They'll boss other people around. They'll say, you do this, you do this, you do this, right? I want to be a manager. And they won't do their job and the project will tank. So you don't want to hire a leader into a non-leadership role. And it is unrealistic to expect to go into a leadership role right out of college, even if you're from Harvard or anywhere, right? Yeah. What I mean is, business school. Even if you go to a business school and did MBA or something like that, which purportedly prepares you for leadership, right? It is unrealistic to expect to become a leader immediately. You got to serve under a good leader. And again, you got to pick a good leader to serve under. You can't serve under some, half-ass leader. You got to, in the interview with the hiring manager, you got to figure out what is the personality of the hiring manager. Is that a hiring manager that is more interested in giving you stuff to do and then disappearing and saying, all right, 1 day later, have you done it? Right? Not a good hiring manager. A good hiring manager is able to describe a problem and think through the problem with you on a whiteboard and say, this is clear, right? This is how it works. Can we do this, right? And then say, all right, good. Now let me go and solve another problem with someone else, and I'll come back and check. If you need me, just call me, right? That's a good hiring manager. And you can get this, you can get a feel for this in your interviews, right? Anytime you go to a decent company, you're going to interview with 5 or 6 different people, and then a hiring chain, right? So all the way up to VP and CEO, right? So you're going to do a flat interview and then that interview. And when you do that interview, we can figure it out, right? And if you're really good on your material, you're solid on your material, when you're interviewing the vertical interview, the horizontal interview is with your peers, right? The vertical interview is with your hiring manager and seniors. And when you do the vertical interview, you won't be on your defensive, right? Because I know that even people that are totally comfortable interviewing with peers, that is, people that you'll be working with in the same team, they'll be totally comfortable. But the same people, when they're interviewed by the hiring manager of the role they're going into, and then after the hiring manager, the VP, and so on and so forth, they go into a defensive mode, and they're not able to think clearly. And because they think, well, these are peers, they can, I can, even with peers, a lot of people are intimidated, right? Because I know a lot of interviews with the horizontal interview, even there, many of the candidates are, shy and fearful, and they're always trying to validate themselves, saying, "Oh my, I don't want to open my mouth and say the wrong thing. I want to." So they're always fearful. They're not putting their best foot forward, right? They're only firing on 10% of their cylinders. So getting to the place where you can deal one-on-one on an equal footing with your peers, the horizontal interview section, that itself is a challenge. You need to practice maybe 10 or 15 interviews, before you get to the place where you're comfortable in the interview. The second stage of getting comfortable with the interview is being comfortable with the vertical. That's harder because there you're actually going to be dealing or interviewing with a person who is going to be your boss or their boss, right? There, it's natural to feel intimidated, saying, well, that person has the power to fire me. And so, so you'll be on a defensive. And obviously at that point, that person is not 100% anymore. Maybe they were 100% when they were talking to their peers. They're not 100%. So this hiring manager needs to be aware of that. Okay, they need to be aware that now whatever this person displays to me as their ability, that's only 50% of their ability. Now, many of the hiring managers themselves don't know that. So they'll say, oh, then they don't have that much of a, right? So, but if you're really solid on a material, you can talk comfortably even to your hiring manager, because when you go to the interview, when you're solid on your material and you go to an interview, you are not dependent on being selected by that company. On the other hand, the tables are turned. The tables are turned in your favor because it is not that company selecting you. If you're really solid, it is you selecting among 4 or 5 different companies. Okay, now imagine who will feel intimidated, right? If you're a rock star and you've got some really kick-ass product out there, and some big company comes to you, right? They're not going to say, you know what, come and interview with us. They'll put their best foot forward and say, hey, we'd like to absorb your product so that we can, incorporate it into our company. Then you can ask them, You can ask them and say, well, okay, well, if you absorb a product, what are you going to use it for? Right? And then maybe, company A will say, we take your product and we'll put it in advertising. Company B will say, we're going to take your product and we'll put it in education. And they all want exclusive licenses. And you can say, well, you know what? I'm more interested in education. So this product, I'll give it to that company, even though they're paying more money here. So those kinds of decisions, you'll more pleasurable decisions, okay? Far more pleasurable decisions than other decisions that 90% of the people are dealing with 90% of the time every day. Okay, most people are dealing with decisions under pressure when they don't have they don't have any favorable outcomes, and they have to choose between unfavorable outcomes. Right? People who are not solid will have choices between all unfavorable outcomes. People who are solid will have choices between favorable outcomes. And choosing between favorable outcomes is a beautiful, pleasant navigation, isn't it? Because you're going from one pond to another valley to another, all these beautiful places on earth you can visit one after another. Whereas if you didn't have that, you'd say, well, I need to get there, but I know to go there, I need to go through this ravine and this desert. There's a desert here and there's a ravine and there's wild animals. I got to, right? So you got to forcefully choose, right? Which is the least risky thing, right? Here I could get devoured. Here I just fall off a cliff, so I'll go this way, right? So those are bad decisions to make, and your mind is always, fearful. Whereas the other way, you say, well, this way I can go through a beautiful valley. Oh, that way is a creek. That way is a garden with fruit flowers and fruits and everything. So you can choose that way, which is a better choice, right? So being solid is where you can get better choices to make in life. And therefore, you'll be happier. People who make bad choices, or people who don't have good choices to make and only have to pick among the least of all evils, right? Picking the best of all good is the way to live life. But most people live their lives picking the least of all evils. And therefore, they're always unhappy. And all people, people are unhappy will make other people unhappy too. The happy people will make other people happy too. And so everybody wants you, and then your social life will automatically grow around you. Right? When you're a happy person, lots of people want to be with you, right? So everybody, you get invited to parties, and even parties, right? You can pick and choose and say, well, 5 different parties I got invited to tonight. Which one should I go to? Whereas, if not so good, and you're unhappy, nobody will invite you to a party, right? You say 5 different parties happening. Which one of these people can I convince to invite me? By saying, can you please invite me? I'll bring a nice bottle of, wine, or, please invite me. I'll do this, right? You got to tempt them. Whereas here, they got to tempt you. So be in a position where you are tempted by other people. You never tempt other people. And mastering material is the surefire way of getting there.
That was actually pretty insightful, because it didn't occur to me before how, I suppose, worthless some leadership stuff would be on a resume, right? Because now that I think of it, it's like
it's good at after a certain stage, yeah, for sure.
Yeah.
But very young newbies putting it on their resume is what is very funny. But after a while, after you've been a director for a while, then you have some really solid stuff to put in a thing, right? So you can say, oh, you don't have to say I was a leader, right? Never use the word leader. There are no leaders, okay? There are no leaders. There are just people doing their own shit and people following them. If someone says I'm a leader, I've done a leadership job, they're not a leader. They're basically just trying to ape someone, right? So a real leader never calls themselves a leader, never says I'm leading. They'll just do their own thing, and everybody around them will say, wow, that person is so happy. I want to be like them. Let me do what they're doing, and they follow you. Then you're a leader, even though you don't say you're a leader.
All right. I want your input on one last thing, but I promise this one will be shorter. So, yeah, so I'm currently in an electrical engineering program, but it's not like I have my heart set on it. I'm kind of just, here because I had no other option that appealed to me more. Right?
No, I'm an electrical engineer too.
You are too. Okay. So, do you have any insight into how one might go about choosing whether to focus more on hardware, focus more on software, or like kind of which direction to go with that?
All right. So essentially, ultimately, everything will boil down to the same thing. Whether it's hardware or software, ultimately everything will boil down to the logic and the math of it to see what needs to get done. Hardware, I don't know, it's just a cup of tea. When I did electrical engineering, I also had to do, wire up transistors and use a breadboard and do these circuits and, oscilloscope and shit like that. It's fun, right? It's fun. But hardware, in my opinion, is like choosing between doing research in math versus building planes. Right? Planes, hardware, anything to do with material stuff has costs associated with it. So if you decide to major in hardware, then you're inherently bound to work for, Intel or ARM or AMD or one of these people that are building chipsets. Or you have to get funding and build your own chipset, right? So you can go to a VC and get funding saying, I got this, VLSI diagram that I need to make into a chip and sell. But you got to be really solid, and hardware is slower to realize your dream than software. So if you are of just an analytical mindset and just want to say, I want to do something really cool, the cheapest way to get there is math or computer science. Computer science, because you can actually produce something tangible also, right? Eventually. So software, I think, would be a good bet if you want to, if you just really fast get things done. Hardware, you got to be patient. You got to be more patient. I think, even in software, you got to be patient, but it's a different kind of patience there, right? In software, you may be intellectually ready, but physically tired, and you can that's a different kind of patience. But with hardware, you can also get physically tired, and you got to wait, even though your mind is like firing rapidly. You say, I have a ton of ideas I need to try, but I can't wait until that the chip comes back from the fab. Yeah, and those are all things that you got to work into your calculus while you make these decisions. But at the end of the day, none of this is just because you're a hardware engineer doesn't mean you're not going to cut software. Yeah, you're going to be running software. You're going to be, once you're solid on software, you're going to be running software. Ultimately, at the end of the day, even when you do hardware and say, I'm going to make this VLSI chip, inside the VLSI chip, there's a program, right? A program has been coded into the logic of the chip. But that program, was first run in C++ or Java or something like that. They tested that program out. And when they're sure that everything works perfectly, then they take it and burn a chip. Okay, this chip is going to go into that unit of my deep net so that it can do these, linear algebra operations really quickly on floating point. And so you're going to take algorithms that have been tested out and then bake them into the hardware. And the reason that latency is there is because also testing things out in software is cheaper. And if something goes wrong, you haven't lost a lot. Yes. With hardware, I don't know. At least you've lost time. You got to make the chip and come back. And even if it's a slight mistake, or even if you missed out an opportunity to make it more efficient, right? That entire fab is wasted, right? Because you're going to make a new chipset, and so you got to factor those things into consideration and say, what is it that I can get the most bang for the buck? With putting the least amount of effort into and having to wait the least amount of time before I can get my ice cream. All of those things you can consider. Yeah, I hope that answered your question. But
yeah, I think that was pretty good. Thank you.
and once you're an electrical engineer, I think it goes for anything, right? Engineering in general. Once you have a solid grasp of physics, ultimately essentially it's physics, isn't it? Whether it's electricity or mechanical motion, it's all physics. Once you have a grasp of physics, it is not just, even if you say I'm not going to do it anymore, I'm just going to go into computer software, it doesn't mean it's gone, right? It is that whatever you learned in physics or electrical engineering is going to play out in your programming, right? The way you think about things will be dictated by what you learned there. Because in learning science and physics, or any engineering for that matter, you're going to control, right? If you want to, in electrical engineering, for example, if you want to do an experiment on an electric motor to current versus torque or something like that, right? Plot a chart or a graph or something like that. So your professor is not going to say, well, here's a motor, here's a belt, here's a go and do the graph. No, they're going to say, no, you got to make sure you got to connect an ammeter here so that you get the exact current. You got to make sure a voltmeter is connected so the voltage doesn't dip. Right? Because when the motor starts running, the voltage is going to dip. So you got to make sure all these controls are in place. And then the belt, slack them up with the correct kind of nuts so that the tension doesn't change while the thing is running. So you got to control for all these things. Yes. Otherwise, your measurements are all going to be wrong. So, and the same thing when you're in middle school and you're doing an experiment, and your physics teacher says, well, we're going to figure out how long a pendulum takes to swing as a function of the length of the pendulum. Yeah. So again, you got to control for these things, right? You can say, I'm going to swing this pendulum inside of water, and this one is in air. You can't compare the two times. They're different. You got to say everything is going to be identical. Otherwise, I can't control the command, right? So that is called getting a sense of control. Now, not controlling other people, controlling the experiment. Controlling the experiment is where you say, I'm only interested in one thing. So in experiments, what we have, no matter what the field is, we have the manipulated variable and then the responding variable. Yes. So the manipulated variable, traditionally, we put on the x-axis, saying manipulated variable changes like this. And then there's a responding variable. When the manipulated variable changes this much, the responding variable changes that much. Okay, that much. So you get these points and you plot the curve. Yeah. Now, if you have only 1 and 1, the curve makes sense. But suppose you have many manipulated variables and you're not manipulating all of them. You're controlling one and the rest of them are just free floating. Then your experiment doesn't make any sense at all. It could be jumping left and right. You have no reason, right? So you develop a sense of controlling for one thing, exactly one thing. And a lot of what we learn in science, in physics and chemistry and all these things, is getting a really, really good sense of what are all the things that could affect it that I cannot see. Because, things that you can see, you can control easily. Yes? But there are lots of things that you cannot see, but still affect your experiment. Like, for example, maybe there's a gusty wind, and you can't see the wind, and it affect the pendulum motion, right? So you want to put in a glass cage or something like that. So there are things that you cannot see that will affect your outcome. How do you spot these things? Now, people say, well, you can, it's just, you can be told what those things are. No, you can actually spot and mentally come up into it. What are all the things that could possibly go wrong because of things that I don't control? Identifying those things is a skill. And many years of doing lab sciences like physics and chemistry are what prepare you for that, right? Or electrical engineering, any of these things prepare you for saying, I'm going to run an experiment. I'm interested in only one thing and lots of things. This is dependent on lots of things. Or, what I'm interested in dependent on lots of things, but I'm only interested in seeing what that thing is going to affect on this. So I'm going to make sure everything else is constant. That's controlling everything else. So that is the exact mindset you will find will play out in computer science when you have a bug and your program, when you run a program, does not work at all. And you look at your program, it's not working. There's like 5,000 things that could go wrong. Maybe a pointer here, a pointer there, some for loop or corner condition there. Okay, how many things? So when I look at program submissions that come in, grind mode, in fact, that is one of the heuristics I use in my algorithm to detect whether two submissions are in grind mode or not, right? So when you're just in grind mode and you have 5 things failing at a time, what I see come in are students who don't control for the 4 things and test one thing. And so they get unpredictable behavior because, this thing changes, but this does not change according to that change. It's changing according to something else because something else changed also, and they didn't even know. So you get a very good insight of what to look for and what to control in computer science so that your debugging process will not be a pain in the ass and you can debug easily. Right? Beginning programmers always find debugging to be a pain in the ass because they don't know what to test for. They're testing a million things and they're getting tired testing. That is a sure way to get tired. The way to not get tired testing is to say, I'm not going to test everything. I'm going to do only one thing. That way I won't get tired. But how do you get a sense of what to test? That comes with practice and doing lots of lab sciences too, because it is exactly the same. The sense of determining what the control is. And in fact, I said something in the 2B subreddit which one of the students actually liked very much. So maybe it will help you too. Apparently, and in fact, when I read the sentence later, it actually kind of rings nicely to me also. So what I wrote, I think, was ordinary programmers get very good at making at fixing their programs for visible errors, right? Anything that ordinary programmers are good at adapting their programs for all the visible errors, but extraordinary programmers find out how to make the invisible things become visible. So there's a lot of invisible things around there, right? In our universe, 99% of it is dark matter. We don't see, we can't, nothing, it doesn't respond to any of our instruments, right? Like that. There are lots of things around us that are invisible. When you walk on the road, there's so many people that are kind to us, people that, park, step out of your way so you don't have to curve and go. And many times that's invisible to us. We don't even recognize that they're the gesture of gratitude. We don't say thank you, right? And it's invisible, we don't know. And we come back home and say, nobody was kind to me. Nobody likes me, right? And that's the attitude many people have, even in life, saying, I have a hard life because nobody likes me. I'm having unhappiness everywhere. But the truth of the matter is that happiness and gratitude and kindness everywhere around you, but people don't see it. We got to get trained to see it, just like programming bugs too, right? So there's lots of things out there that are invisible, but by getting really good at it, you'll know, all right, these are all the things that could potentially be wrong. So let me surface all of them so I can visibly see them. And the debugger, as you know, is one of the ways in which you can make some invisible things come true, right? Some raw invisible things, right? There are things that can't even be surfaced in a debugger, because in a debugger you can say individual variables which normally aren't visible to the user. You can have it in a window as your program is running step by step, and you can look at the invisible things and say, hey, you know what, X invisible to the programmer, but it went to -1 all of a sudden, program will crash. Okay, so that is one way of making things visible through the debugger. But there are lots of things. That is like the tip of the iceberg. What you can see in the debugger is the tip of the iceberg for what is actually out there that you cannot see. There are so many things that could go wrong in your program, and only a small fraction of that you can see in a debugger. That is why many expert programmers will not even use a debugger. They'll use print statements, cout statements to debug their program, because some of the complex logic you can't debug in a debugger. You need something to happen, and then some result variable to be printed out to the console. And looking at that, you'll know what's going on. So there's indirect ways of making things come visible. Just like, that star and there's space-time, you can't see space-time directly, but there's an indirect way. The light will bend because it follows on space-time. Right? So you can make it visible, even though it's not visible. And so programming in algorithms, you'll say, well, this algorithm is not working. Everything I see seems to be right. Something I don't see is probably not going right. So let me see, where are the places that I don't see things happening? Oh, right at the beginning of the for loop. I don't know what these corner variables are. So let me do a cout here and here. Okay, so and those things you won't even see in debugger, and because that's a result of some computation. So so you'll get really good at making the invisible things become visible, right? When you can make invisible things become visible, you're the top magician in the world, right? C++ at your side, and you can do whatever the hell you want, because you know what's going on, you can control for it, and you know all the bad places, you can steer away and go far away. You can maintain maximum margin from all the bad places. Otherwise, you'll be going close to them. So so those are things that will help you greatly in your career as a programmer. And never go for grade. And even after you start working, I told my son also, never go for title, job title, or anything. Okay, because in the past there are people who wanted to become program managers or project managers or product managers. Yeah, product managers. They want to become product managers. But they really weren't as interested in the product itself, and they still wanted to become a product manager. And so I couldn't figure out why do you want to become a product manager when you're not interested in how users are going to use this product? But it turns out that there are a significant number of people out there who want to become a product manager because it has the word manager. And many people think manager means you have people under you, and you're telling them what to do, and you're a boss man. What kind of a stupid way to feel superior is that, right? It's all sham. It'll disappear, right? And so product managers aren't managing people. They're managing a product and saying, this product needs to behave properly in the way the user wants it. I can think like a user, so I can manage the product and tell the engineers, hey, this is what the user wants. Can we do this? Can we do this? Can we do this? Right? The product managers aren't managing people. But there are so I said, never forget about the title, okay? And never ever apply to any job based on the title, or whether it's director or manager. Don't care about any of that. The only thing you should look for is how interesting the job is, because it needs to be interesting. Never make the mistake of going to a job which is not interesting just for bread and butter. And the reason I say that is because once you get into a job that pays for your bread and butter, but is not interesting to you, that is a very high risk of settling in life. Why? Because it pays for your bread and butter, but it's not interesting enough for you to go more. So you're never going to get better at that job. You're never going to get promoted. You're never going to do anything else. And to make matters worse, you're never ever going to do what you actually love in life, which may be something completely different, because there was another job which was something that you actually liked, but you went to this job because it gave you more money and a better job title. So, but now you're stuck here at this position, which is slightly higher than this, maybe. You're stuck. You're never going to go up because that's something that is a dead-end job for you. Whereas here, you started low, but it was something you liked. And you didn't care about title, right? So you got better and better at it. And people around you started following you because you got better. And all your peers, every time they have a bug, they'll say, well, let's go and ask Eric, or let's go and ask Ping, right? Because they always trying to figure out these bugs, okay? And your managers will start noticing that and say, hey, that person's always the go-to person. Every time someone has a bug, they go to them, right? So they'll say, the next one-on-one, they'll start, slowly poaching, not poaching, slowly bringing up the topic of saying, hey, would you mind managing the team, because I need to go and do something else. Maybe they want to go off and do another role or some other company, but they want to make sure that the team will still be functional. And they can't just yank any Tom, Dick, or Harry and put them in a management role. They want to put someone in the management role that the other people will still continue to look up to. So by just being good at what you do, other people will pull you up. By not being good at what you do, you have to pull yourself up. And when you pull yourself up, you're going to pull something down. And that person is not going to want that, right? Rather, do something really good, and person above you will say, okay, I'm going to pull that person up now. That's a lot easier. You can rise without doing your own work. The other way, they got to rise every single step of the way with their own work. I don't know if that makes sense or if it's useful, but tuck that away in a corner of your brain later on when you start working, and you can see if that helps out.
I'll keep it in mind.
What was that? Was that useful? Okay. Anyway, so that's basically all I had to say. If you guys have any other questions, I'm happy to answer them. Otherwise, like I said before, take this opportunity, just converse. And what you're practicing for is to, in your mind, you can say, some group of us here, we're going to start a C++ channel on TikTok. Yeah, TikTok or YouTube, whatever it is, some media platform. And you can say that this channel is basically going to feature, in every clip, it is going to feature 3 students. May not be the same 3 students, 3 or 4 students who are basically maybe with a whiteboard in front or not with a whiteboard, that's also fine. In this channel, in these 5-minute clips, we'll have 3 students talk about an interesting problem. Right? And it's not a leak code problem, right? You don't want to do another leak code saying, oh, here's a problem, go and solve it, and this person will tell you how to solve it. There's a ton of videos like that. Don't do that. So make it different and say, these 3 problems, these 3 students are going to take some data structure, let's say a linked list, okay? And say, and I'm going to look at some interesting thing to do with a linked list and say, hey, you know what? I want to try and find out if there's a cycle in this linked list. And none of you know how to do it. And you're going to try and brainstorm. And this 5-minute brainstorming session, you can have a rehearsal brainstorming so that you can, edit out all the parts that are not interesting. You can have the actual brainstorming, and that would be a really interesting video, right? 5 minutes just to get a really good intuition about some interesting transformation of a linked list. Not a leak code problem, not likely to get you hired immediately, but it's something that will give a hiring manager insight into how you think, and that person is interested in the problem. Not in solving the problem, but in how the problem gets solved. And so you can practice that. You can practice that, right? So right now, maybe it's all of you, but you can eventually say, well, we'll do a talk show, not talk show, right? These segments on TikTok. And we'll, out of these 10 people, we'll have 10 groups of 3 people each, right? Overlapping, right? Same person, maybe in multiple groups. And then this season, we'll have 10 5-minute clips. Right? First clip, we'll talk about linked lists. Second clip, we'll talk about nested vectors, right? What are these things we can do with this? and make sure and try. Maybe initially you'll just pick a problem from LeetCode or some other site, but eventually you'll find a way. In fact, if you go to my CS2C section, a couple of my 2C students are having an incredible discussion right now. And I made a post in the subreddit saying, I wish you guys could have this exact same discussion on video and post it in a video channel, right, somewhere. Because that is a very interesting discussion, not out there. They're talking about how you can take something called a trie data structure. It's got a prefix tree data structure. And they're talking about, this is a data structure, how can we make it more efficient? Or how can we how can we use some other data structure inside of it to make some aspect of what we want to do easier, right? These are very specific things to maybe some group of interesting people, right? Saying, hey, that's really interesting, I want to watch it. And maybe at the end of the 5-minute video, many people who are watching it will say, you know what, there's an interesting direction, we could go from there. Maybe let me get in touch with those people and say, hey, can we have an extended discussion continuing on from that? Part 2 of that, that video, where we can talk about this angle. All of those opportunities open up for you. Yeah. And creating media, creating useful media, creating interesting programs and sharing them. I think that will be a huge part of the future, whether it's games or content of any kind, because with information transmission becoming so cheap and commonplace, I think in the future a lot of really cool things will get done just by virtue of the right packets of information being exchanged. This, information, higher level information like concepts and all, from one person to another. Right now, we're just exchanging variables and counters, but in a higher level cognitive system, higher level concepts will be exchanged. Yes, and so I think that's where the entire internet and the human population is gearing up towards. So yeah, practice just chatting, right? Initially, it'll not be easy, maybe, or it'll look very contrived, but you'll be surprised. Just like practicing, initially it looks like I'm hitting each key after a couple of seconds, but after a while, I'm just talking to someone and I'm just playing it. Yeah, and you don't even know, and that's how it will become, right? Like a talk show host. Just happen, ordinary conversation, no preparation at all, anytime, off the cuff. Just grab them and start talking to them, and it's an interesting conversation right off the bat. No preparation, right? And that'll just become second nature to you after a bunch of practice in any area, not just computer science. You guys want to talk? You want to talk? I'll just turn the laptop around to face the garden, and then I'll just be here. If you want to call me, you can call me, but otherwise you can just talk about anything you want. Okay? Great. Thank you all. And if you guys want to meet again next week, just set it up. Let me know, confer amongst yourselves, and just send me an email saying at least 3 or 4 of us want to meet. Can we do the Zoom session next Friday? And I'm happy to talk again. Yeah. Otherwise, I will hope to see most of you in my 2B at some point, or at least questing on the site. Even if I don't see your faces, I hope to see you questing and having fun. Thank you all for doing CS2A. I had a great blast teaching you guys. And it's a very interactive and interesting crowd of people committed to learning, and commendations for picking the hard section, even though because I go to rate my professor sometimes, to see what other people are saying, and I see my page apparently only has red. Everybody says awful, right? You get no help. Nobody teaches you anything. You got to learn on your own. So, but some of the other sections, lots of green. So I think okay. Maybe lots of people are finding it really hard, but then I see you guys and say, well, obviously these people are they're not fools. They've probably looked at Rate My Professor and still enrolled in this class, right? So they actually picked the hard class. So that is absolutely fantastic, right? Even I didn't do that when during my first couple of years in college. The graduate, right? So in undergrad, I didn't have a choice, because when I did my undergrad in electrical engineering, it's not like these days. Right? Back in India, there was a fixed set of courses everybody had to do, right? I can't go pick and choose saying, well, I want to do 303A. Do I pick this professor or that professor? I take that one. No choice for me, right? Everyone who's in this particular section has to go that, like high school, I think, or like elementary school. And but now you have the choice, and but you still pick this class. So I'm very thankful to for that, and I will hopefully see you all again. Okay? All right. See you guys.
I had a question on Quest 9. So I'm currently getting an error on the, I believe, the get size. So pretty much I got 2 errors so far whenever I try something. So one is I get an empty list error saying the size of your empty list is not 0. And when I define size equals 0 in my constructor, then I get a broken pointer error. I'm not really sure how to go about this. I've tried a few different things, but none of them seem to work and they keep giving the same error.
Wait, so when you define size as 0, you get a broken pointer error?
Yeah.
But size is just a size underbar T.
Yeah,
type.
that's what I was confused about because when I remove it, then I get a different error saying your empty store is not 0.
Store? Are you, wait, store? Like,
Sorry, empty list, my bad.
oh, okay. Yeah, because all I did, like I got full credit on the quest. All I did was, it's the data type is declared in private of the class, right? And then in my constructor, I just said underbar size equals 0.
Yeah, that's exactly what I did, but then I get a broken pointer error, even though I don't see how I get that. And I only increase and decrease it in
The
I
ones that
believe
increase and
it's,
decrease.
insert at current and the clear function.
Can
Yeah,
you try
remove
because-
it.
submitting again? Maybe it might change.
No, I just submitted it again like 5 minutes ago. It didn't
Oh,
change.
it still said broken. So could it be somewhere else that you might actually have a broken pointer? It might not just be like size. Or it might not just be in your constructor.
No, because when I remove it from a constructor, I get the empty list is not 0, 1.
Okay.
So I'm
Okay.
pretty sure it's something with that.
Yeah.
And I believe my destructor is also correct because I'm just using the clear function and then deleting head just like the instructions told.
Why
So
don't
I
you try to just comment everything out of your destructor for now and then see if anything changes.
the destructor? Okay.
Yeah, just leave it empty for now.
Okay. Sure. Yeah, let me
And then try
that.
submitting and see if anything changes.
Okay. No, now it's saying I have a broken pointer somewhere.
Oh, it's still
I typed
okay.
something that wasn't mine and got terminated for it.
Do you have an IDE that we could that you could work with? Or are you just using a text editor?
I'm using VS Code at the moment. But I don't think we're allowed to share our code.
Yeah.
here.
Yeah.
Oh yeah, that's right.
Wait, I had a question. I guess this is one way to go about it, but in what function did you guys increase or decrease size?
So for me, what I did, I took his advice in the PDF, the instructions, where for my push back and push front, I called insert at current. So the only time I increased size was inside insert at current.
Mhm.
And that's it. And then obviously I do size minus minus for the
Remove.
yeah,
one?
but so
Yeah.
then I only do size plus plus once in my entire code.
Yeah, I did that too. Yeah.
Okay, what about for clear? Did you guys do that as well?
I did
Or-
size minus minus.
Okay.
I decremented
Oh,
size.
yeah.
If you do clear, then is your size reverted to 0 then, or what is it reverted to?
No, I think in clear, I put it in a loop. So it just
Or
does
did
it
you put in like a
automatically.
while loop, while it's not equal to null?
Yeah.
That.
Yeah. While
Oh,
head
well, yeah.
That's
misses.
exactly like what I did, but I don't know why I'm getting this error.
Well, yeah, for my clear, what I did was I just I took advantage of my remove at current. And I just called that multiple times until size was 0. And because in my remove at current, it's size minus minus. But yeah, I didn't run into that.
Yeah, that's why I'm kind of confused because I don't see how I'm getting an error now,
for
let alone a
pointer.
broken pointer anywhere.
Okay, so I did run into some really odd errors because I didn't allocate memory. So when you made your node, you said new node, right?
Yeah, I did.
for new.
And then I gave it the value. For the constructor, I gave it the value sentinel that was written.
Okay.
Did you send its next set its next to null pointer?
Yeah, no
Okay.
PTR.
And then you set everything else like the head, tail, and
I
previous. to
pointed
current,
all of them to that node.
Okay, that's exactly what I did. I don't know then. Is your wait did this always happen? Like, did you see if your other methods were correct?
I already posted this on the Reddit, but the first two, which is constructor and then the sentinel, I got the points for that one.
But nothing for anything else, right?
Nothing else, yeah.
Okay. Hmm.
So you got constructor and sentinel, and then you didn't get size.
Yeah, I believe the next one was the get size then. But for that, it's just a one line where you return the size.
Yeah.
So in your get size function though, it's just return size.
Yeah. I tried like just going through everything, like opposite what the PDF was saying at some point, but then it just said that's only a read-only function, so I couldn't really try that out.
Well, do you want to see out size? Like well, you're not initializing it. So when you don't initialize it, it's some bogus value, right?
Yeah.
Oh, okay. Um,
Did you put size inside the constructor?
Yeah, I did. That's why I get the broken pointer error.
So can you walk me through your insert at current? Because there could be something
Oh
wrong
yeah,
there too.
sure. Let me open that. Okay, so pretty much I'm creating a new node first, and then I give it the value of s that's inputted in.
Yeah. Okay.
And then after that, I say that this new node, the next thing is equal to the previous to current next. Do
Yeah.
you understand what I'm meaning?
Yeah.
mean
Yeah.
by-
Yeah. Yeah. Yeah.
Right. And then I point the prev to current pointer to the new node, and then I increment the size of that.
Okay. So on the previous one, I added an if statement where it's like if the tail next is not equal to null, then set the tail to the tail next.
Wait, for which one is it? For which one?
So right after you set the previous to current pointer to node, right?
Yeah.
I added an if statement where I said the tail next is if the tail next is not equal to null, then set the tail to tail next.
Right, that's exactly what I did. I said that if the new node, the next node is equal to null, then set the tail to the new node.
No, not equal to null.
Wait, so you're saying that if the next one, that wherever net tail is pointing to, if the next thing is not the null value, then tail is equal to the value after that?
No. If the next if like the next item from the node it's null if it's null pointer, then set the tail to the new node.
basically, I mean, what I have an if statement that's not exactly the same, but I think it does the same idea. It's basically checking if what we're inserting is going to be a new tail. And
Okay.
then we have to update
Yeah.
tail.
Oh,
I'm
okay,
gonna-
that makes sense.
I don't
I'm
know
gonna-
if that's related to your problem though.
I mean, I had a bunch of problems that got fixed just by
When you
like
did that.
yeah, so
I'm gonna send you the pseudocode here.
Yeah, that would be good. But would this really like affect the get size method?
It
I don't
could.
think
I
so.
don't know. I'm just seeing what I have different from yours, and maybe it
Well,
might.
And since you're using VS Code, could you in your like if you have a main, right? Like can you just make the object, I mean string list, right? And then could you literally just say stdc out get size? Oh no, but you can't even declare it. I mean you can't even
Yeah.
So yeah, I put it in chat.
C++ file to like run various functions on.
Okay, wait, let me try what you said. Okay.
And then increment size after that, and then return this.
Yeah, I did that already.
Okay.
Um, Now it's saying it's still getting the broken pointer somewhere.
Really? Oh.
Yeah.
Um,
Okay, so for me, this won't work, but like just like a check, like I didn't set size equal to 0 in the constructor. So it was some like bogus value, but it was still like workable. Like, it wasn't, it wasn't a finished product, but like since I didn't set size to 0, it was some bogus value. But like, would that let you get past this pointer error and just kind of see like,
No, then it gives you like an entirely different one saying that the empty list is not 0. Like,
okay,
it's probably because of that bogus value then.
yeah, okay.
Is there like anywhere else you can initialize size is equal to 0? By any chance?
no.
And
Really?
you're doing, it's like, so there's no like star or anything next to size, right?
Yeah, there isn't.
No, because it's not a pointer.
Yeah.
Yeah.
Yeah, I don't know. Honestly, like because everything like yeah, I actually don't know.
I've been like
So-
struggling with this problem for like 2 days now. I like
Is it-
rewrote my code twice for it.
You made sure to use like this, right? This
Yeah,
dot
I
previous
returned
to
this for
current.
all the functions that start with string list.
Okay, yeah. Okay, good. Then yeah, I have no idea.
Okay, well, when you run it in your IDE, does it like show like will it say the same thing? Like if you run in your IDE?
What do you mean? Like,
So in VS Code, right, you can run it like through terminal or
yeah, you could.
so like would it show the same error? Is this a syntax error or a runtime error?
No, so when I don't set size to 0, I get the size of your empty list is not 0 there. But then like when I run it, it shows 0. So I'm not really sure.
You could do 0U. Actually, I don't know.
For the constructor, did you guys just create a new node and then you point everything to that dummy head?
Yeah,
Yeah.
Yeah.
And then you put the size equal to 0.
yeah.
Okay.
Did you do that as well, or did you do
Yeah,
something?
so you create a new node and then you use a dummy head to point at it, like a pointer point to it. And then everything else point to this same node as well. That's
Yeah,
what
that's,
you did,
that's
right?
pretty much what we did there.
Oh yeah,
So-
by the way, for the first node that you create in the constructor, you made it a pointer, right? Like you added the star and then under
Yeah,
and
yeah.
then- okay.
And then it said new node. as
Yeah,
well.
yeah. Okay, then.
Because I got the same error to like you something like returns to be 0 or something like that. And then I just changed something to the constructor and then I finished the what function step, like the get size function, and then the error just gone.
Yeah, that's why I'm confused because like my constructor is pretty much matching like everyone else's here, where we just create the new node and then all the other pointers point to it.
Mhm.
And then the next one is null PTR.
No beating.
But you guys are saying you guys set size to 0, but whenever I do that, I get an error somewhere.
And you say you get an error about like pointing
A
to
broken pointer then.
broken.
Did you
Didn't
double check
really
you
make
copied?
sense.
Did you double check you copied everything correctly from the template? If you may have like some things missing.
I can check again. Let's see. Everything looks the same.
Okay. Yeah.
Is there anything special with indents for the public and private part? I mean, not for C,
No,
right?
I
Not for
mean,
C++.
they're indented just like the template.
Wait, so sorry, I kind of asked this already, but I wasn't sure what you meant by it. So it's like if you say like if you type the line, underbar size equals 0 in your constructor, is that a syntax or a no? It's not a syntax error, right?
No, it's giving you a broken pointer error.
Um,
Is it
is that a runtime or
that
a
syntax?
syntax?
I don't know.
I'm not sure.
So like
That
when
could be
you
runtime.
type it, is it a red line or does it
No,
compile?
there's
fine?
no red line.
Okay,
Yeah.
so could you like put underbar size equals 0 like in your constructor? Can you like, do you have like a main that you could run it and just like declare this object and literally just say like cout get size? Like in your own compiler and your own IDE if you have that set up.
Yeah, like do a main.cpp and include the string list.
Yeah, okay.
Do you guys know what's the maximum point for Quest 9?
I believe it's
33 points.
33.
33. There's a hidden 5 points for 2 string at the end.
So you mean like that's extra 5 points after 33 or is including the
No,
first?
no, no. The max is here. I have a picture of all the points. There's the last 5 hidden flutes of marigold. That if you don't get them, it doesn't complain.
So after you get the 5 hidden point,
You're
your
done.
total is 33, right?
Yeah.
Oh, okay. Yeah, because I was thinking like, did you guys like get 38 or something?
No, 33.
Okay.
Yeah, here it works saying size is equal to 0. When I say get size then, when I just do the constructor.
Huh. So do you want to try like pushing and I mean,
Wait, is it just possible to declare size equals 0 in the private area where it says size? Would that work or?
I
No,
guess that so size underbar t size, and then you could just say equals 0.
yeah, and then I
Um,
remove that from the constructor.
Let me try that in my code. and
You
see
can
if it works.
actually change private to public. That's what I did. And then I just test it like directly with the member.
Oh, wait, so you put underscore size in public then?
Like, are you talking about the string? I mean, the string list class? Like, for example, like the members, they are all private, right?
No, I'm just talking about the underscore size variable here. Would that
Yeah,
work?
if you want to change that, and then you just change the public to private, and then you can just access the size directly.
Hmm.
How about you try, so since right now it's working with 0 in your own compiler, why don't you try like adding like, 1 element and I mean, see it increase and run that in your own compiler.
All right. Wait, could you try what you were saying before if you make size equals 0
In the where it's
on
declared,
yours?
yeah, it works as well for me.
So wait, let me maybe just try that.
Okay, but this is in my own compiler, so I mean,
Is it possible to run that on the questing thing or?
actually,
Yeah.
sure, I can do that.
I think it should be.
So I got rid of it there. Just give me a second. Yeah, so it still works that way as well. So if I say like where it says size underbar t size underbar t underbar size equals 0, and then I say equals 0 there instead of the constructor. So I don't even I don't even like do anything with size in the constructor. It still works.
All right. I'm just hoping this works.
If not, I'm thinking it must be somehow like a different function, like
Maybe
messing
push
with it.
back.
Yeah, I'm
Yeah.
still getting the broken pointer, so maybe it is a different function then.
So,
Yeah.
Did you guys do any other if statements in any of the other ones besides insert at current?
For the tail,
In advanced current. I did one in advanced current and get current.
Yeah.
Oh, yeah, for those ones, but that's because you have to like compare it to tail.
Yeah, yeah.
What about
Uh,
for remove at current? Do you do it there?
No.
Okay.
Wait, can you go over your pushback?
Yeah, sure. So basically what I did was I used insert at current as well, by the way.
Yeah,
Yep.
yeah.
Okay, so I did a temporary pointer, which is pointing to where previous to current was pointing to. And
So
then
you, previous to current next or just previous to current?
no, just to previous to current,
Okay, okay.
right? And then I set previous to current pointing to what tail is pointing to.
Yeah,
And then I did insert at current there.
yeah.
And then after that, I said tail points to previous to current next.
No,
Is it there? Wait.
that's I didn't need to do that. No, I did it. Previous to current is equal to the new node.
Oh yeah, oh yeah. That's what I did the step after.
I don't think you need the step before. Try
Wait,
commenting
wait.
out. I didn't need to do that.
Okay. Wait, did you
Wait,
delete anywhere?
Can
Like,
you?
Delete
like
what?
did you
Like,
delete
what do
the
you mean?
temporary pointer or
No, I didn't.
okay. Let's see.
So just set this previous to current to the new node, and then I think maybe
Yeah.
okay.
Wait, you said previous to current to the new node you're making?
Yeah, that you made in the method.
Oh, really? I set my previous to current back to temp.
Oh wait,
Where-
it passed that error now. Yeah,
Oh,
I did
Okay.
it.
interesting. I didn't have that line.
Okay, that was interesting.
Yeah, you know, when I was debugging insert to current, I also had a problem with pushback too. Like, I think I needed to do those two simultaneously for some reason, or it was
Wait, just to make sure, when you guys
something
created
related
the
to the size.
pointer, right? You didn't delete it at all. Like when you create that temporary pointer, did you ever delete it?
No,
Or
no,
you didn't, right?
no.
Okay.
So what I did was when you create the temporary pointer for like pushback, I just said like node star temp is equal to previous to current. And I think when you declare it that way without saying new, it just goes on the stack, right? And then because it's on the stack, like you're not actually allocating memory for it. It's
Oh,
just
so you only allocate memory when you use a new keyword then, right?
yes, that's my
Okay.
understanding.
Maybe another error I was doing was because I deleted it in like two of my functions. Like I deleted that temporary one, but then I didn't use node. Maybe that's why I got it. Because
Okay.
it was deleting like memory that wasn't there.
Yeah, yeah. I didn't delete anything, so I
Okay, yeah,
just
that
skipped it.
makes
Yeah,
so much more sense.
yeah. So does
Wait,
it show
so-
you points for everything?
Oh no, it shows me points until I got something else wrong.
Oh, okay.
Wait, so you guys were talking about pushback. Did you guys like move where the cursor? I'm calling it the cursor, like the previous to current.
Mm-hmm.
Did you guys move where that is? Because all I did was I copied over. So I said like node star temp is equal to previous to current just to save where the initial, cursor is.
Yeah,
And then I
Mhm.
basically move the cursor to where I want it to be, which is tail.
yeah.
And then I
Yeah.
call the insert at current.
Mm-hmm.
And then I
Yeah,
reset the cursor to temp.
Back
I
to
don't
what you
set-
Yeah,
back
yeah,
to the
right.
template.
Yeah, that's
okay.
exactly
I
what
thought
I
you
did.
guys were
Yeah.
saying you set it to
No, I did an
You know
extra
you're
step where I
implementing.
set tail to pointing to what previous to current next is pointing
Yeah.
to.
No, by new node, I meant like the node that I created
Oh, the
in
temporary node.
yeah, the
Yeah.
Okay.
temporary node. Yeah,
Okay.
yeah,
All right. I fixed mine now, so that's a big help.
yeah.
Does anyone else have anything?
Yeah, for quest state, I'm looking at my top function and I'm getting an error where it says my top function returned false, even though it's true according to the thing. I'm pretty sure my logic is sound, so I don't know what's happening.
So the search, binary search or linear? I mean, sequential.
Wait, no, I'm talking about quest state, not quest state.
Yeah, quest state was the one with.
Which function?
Yeah.
Top.
Oh, top.
Yeah.
So what were you like for top? What were you returning?
So I just followed what the PDF said. So basically, I said if like the vector is empty,
Mhm.
then I'm going to change the success variable to false and return 0.
Mhm.
else success variable is true, and then return the value that's at the end of the stack.
So like at size -1.
At
Oh
size,
wait, I don't know how you implemented it. What'd you put for return?
I put return underscore data dot back.
Dot back. Okay. So you're saying that the top is saying it's false when it's not supposed to be?
Yeah.
Does it give you like the specific test it ran? No, right? Like it doesn't tell
No.
you.
Here, I have it on here. Let me just screen share the error.
Okay.
The other error showed up too.
Wait, can you walk us through how you did the code?
All right. So int top blah 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 function declaration, right?
Yeah,
Yeah. If underscore data dot empty is not equal to true,
yeah.
means success is equal to true,
Mhm.
and then return underscore data dot back.
Okay,
Else success equals false, return 0.
okay. So what error is it giving?
Yeah. Let me
Because
share.
that's exactly what I did. Except I stored I stored the integer into a variable and then I returned it at the end.
Oh, really?
Yeah, I mean, because it had a problem where like if I return inside the if statements, it says that it can't, it needs a return statement, if that makes sense. Like
Yeah.
it don't,
It needs a
it's,
guaranteed return.
yeah,
Really?
yeah.
Interesting.
Did you say data dot empty not equal to true?
Yeah.
Okay, so what I did, I just added
Should
an
be-
exclamation mark.
It's basically like a reversal. I can,
Yeah.
it can basically be data dot empty equals true.
Oh, and then what do you put inside success if it's not equal to true?
Success equals true.
Okay.
Because if I'm
And-
saying if data
If it's
dot
not
empty
empty.
is false, so that means there's stuff inside the vector, then success is equal to true.
So wait, what's your error?
Here it says your top function returns false. Yeah, so checkpoint failed. Your top function said false, but mine said true.
Yeah, so probably, yeah, maybe somewhere you did the opposite thing. Yeah.
You're not returning success, right?
No, I'm not. I'm not returning
Okay,
success. Yeah.
okay.
So you either return
try doing the,
0 or return the last element, right?
Yeah, I'm gonna try doing the way that Aditya said, where like you store the last element in a integer.
Yeah.
That's
So I did in X, right? And then I said X is equal to data dot back. And then for else I did X is equal to 0. And then I returned X.
Oh, okay. Why does that happen? I want to know why that happens.
It could be an issue, but that's an issue I had, so.
Okay. Thanks. All right. So I have another one, and this one is about the string function, the to string.
Yeah.
So in my error, it prints everything out pretty nicely, except it prints out 2 extra elements, and I'm pretty sure that's something wrong with my.
Oh, okay. So are you using
Oh,
a for
yeah.
loop?
Yeah.
Are
I
you
am.
using? So can you change? So what is your I equal to?
So I'm creating. So here's how I did it. So if I first created an if statement. So if the size, which is size is set to like data dot size -1. So if the size is greater than 10, then I have the first for loop, which is I is equal to size, and I is greater than or equal to size -10, so that it would stop at the 10th element, and then I added that into the string.
Oh, actually, don't do data dot size -10. Try just making it 10.
Really?
I think so. I think, okay, so I didn't do it as like, I didn't need 2 for loops. I only needed 1. So what I did was, okay, I created a size ti, and then and then set it to 0. And while it says less than 10, and then I increment it. And then inside a string stream, I put the data, and then the data dot size -1 minus I. If that makes sense.
Can you send the pseudocode?
Yeah, sure.
For my for loop, I iterated backwards.
Okay, so
Yeah, I iterated backwards as well. I went from size -1 to I is greater
yeah,
than
I
size
did the same
-11.
thing. Yeah, I did the same thing.
Yeah, and for my second for loop, I iterated forward so that I would stop right before like the element that you need. Oh, size is equal to I is equal to 10.
Oh, sorry, I is less than 10, my bad. It's less than 10. And then I put it in a string stream. So I went like this, and then I put the data, and then data dot size -1 minus I.
Oh, okay.
It's iterating backwards from here.
Okay.
And then I store that in a string. And then I cleared the string stream. And then I recursively put it in a string.
Oh, I see. Yeah, I think my code is just a little bit too complex for two strings, so I can't really find out what's happening.
Yeah, I had the same one with Quest 9. I made it too complex too.
Okay, yeah. I think, is there any other error?
I mean,
Does
for
top
me,
work?
Top, no, I haven't tested it out yet.
Okay.
yeah, for me, I didn't like the string stream thing. I've only used that because of that decimal quest a
Oh,
while ago. But like I've just been doing, I know this might be bad, but I've just been doing string concatenation because most of these are pretty simple.
Yeah,
Yeah,
that's
yeah.
what I'm doing, yeah. I think for the sixth mini quest for quest 8, I just didn't understand the wording. What does that actually like means?
Mm.
Yeah, what does it mean by when it says except that it has the side effect of removing the element that is returned if the stack is not empty?
Which one? Let me see.
This is another kind of so bool pop, and it has the integer variable.
Oh, that one.
Yeah.
So
I didn't-
basically, when you pop something off the stack, it's like imagine you have a stack, right? And
Yeah.
you pop the top element off. The first pop,
It doesn't store it, right?
yeah, it looks like the first pop just like erases it, right? But the other pop, not only it returns it and then erases. Yeah, returns it into the value, the address value, and then erases it.
Yeah, so what I did was I did another if statement, but this one actually works, I'm pretty sure. So on the else part, I just said I set the value. I pushed the value to the top of the stack, and then I popped the stack.
So what you call a push inside your pop?
No. That's
Oh.
not. No, I meant here. I meant first I did data.pushback val so that it would push the value to the top of the stack, and then I would pop that value off.
Wait, so data dot pushback. Wait, where'd you write data dot pushback? Inside what?
And so I first created an if statement. I put it in the else part.
Okay. I don't think you need to do that because okay, if we just look at the first pop, all we're doing is erasing the top element.
Right.
The only special case is if size equals 0, then we just return false, right?
Yeah.
So all we have to say is, I mean, I use data dot erase. And then, yeah. So then for the second pop, I had the exact same piece of code. I just added one more line. Right before I erased, I said val equals data dot at size -1 or dot back or whatever. So I don't.
Oh, wait, is there again data dot
So
back -1?
well, I said data dot at size -1. It's like at the very end of the stack, which for me
Right.
was the top. Like that's like the top of the stack, which is the
Sure.
very like the end of the array. So internally, the top of the stack is like the end of the vector.
Yeah.
So I was just returning setting val to the most recent element, and then I just say data dot erase.
Oh, okay. Yeah, no, I just wanted to confirm that like val was set to the most recent element.
Yeah, so most recent, which in my case, how I use the array was like the very last element.
Yeah.
But yeah, your two pops should be almost identical, just like one extra line
Yeah.
for the second pop, where you're just like saving that value before you erase it.
Okay, yeah.
And to use the erase function, I mean, you already used that, right? You have to like make you have to say like data dot begin and then like plus size -1 and then like data dot to like data dot begin plus size minus like 0 just to
Yeah.
like get the range or something. I had to look that up.
Yeah, okay. Right. I think that's it. And did you just to confirm that like pseudocode you sent, that was you only used one, right?
One what?
Like for the
Well, yeah,
two-
one for loop. Yeah.
and you would said I is less than or equal to 10.
No, less than 10, just less than 10.
Less than 10.
Yeah.
Oh, okay. And then yeah, okay.
So then you put that, I put that data into a string stream and then put that into another string.
Yeah.
And then I made another string where I recursively added it in
Okay, yeah.
with the new line.
All right, yeah. Okay, yeah, thanks.
And also make sure to clear your string stream after. I think that's, I don't know if that helps, but I guess it's just good practice.
Okay, yeah. All right, yeah, thanks.
Yeah. Yeah, I'm gonna have to leave now. See you guys.
You guys finish all the class?
Yeah, I was able
Yeah.
to last night.
So do you guys do any other stuff for coding?
Well, I code Python. So, well, I used to. I mean,
Wait, what was that? What did you say?
well, I code Python. I used to. I took a class in coding Python, and I.
Like, do you guys like besides taking this class, are you like doing other programming stuff, like doing building projects? Oh,
No, no.
I'm doing leak code and user code.
oh, okay. Are you like?
Oh yeah, I'm also doing user code.
Like, are you preparing for interviews?
It's like a programming competition for like high school students.
Oh, okay. Are you guys using C++ for that?
I was using Python for like.
Java.
Okay. Are you guys going to take 2B next semester?
Yeah.
No.
Wait, are you Richard, are you like a college student?
I'm gonna be a college freshman.
Oh, okay, so you're all high school student.
Yeah, I'm just doing this for GD.
Oh,
requirements.
okay. Did you, oh, you mean like next semester you're going to college?
Yeah,
Which college you going to?
Santa Barbara.
All right, I'm gonna head out.
Alright,
Nice
I'm
meeting you guys.
leaving to-
Wait, so
Bye.
Ping, did you say you finished all the quests, right?
Yeah,
I did.
So can I just like verify the trophy count? Because I want to make sure I got like full credit.
there's one class I didn't get full points, but yeah.
I
Okay.
didn't get
can
full
do
credit
that.
for the serpent one.
But
'Cause it
wait,
was
did you
very-
guys get to like 190?
I got,
No.
wait, I have 188.
Okay.
I
have
think I got full
180
credit.
I have 189 point something.
Oh,
Uh,
seriously, I must have missed something. Could you,
Yeah.
I mean, could you quickly, so like I have like one, could I just like tell you guys how much I have so I can figure out like which one I didn't get full credit for?
1 second. Let me check what was the
I think you should get, first one is 1, second one is 14, third one is 14,
yeah.
fourth one is 24,
Uh-huh.
fifth one is 33, sixth one is
33.
26. Yeah,
Okay.
the serpent one is the one that Yeah.
Which one you guys mean?
So the serpent, I got 30 points on the serpent one. So after serpent, it's 26, 26, 20, and 33.
Yeah. So the second
Okay.
one, everyone's missing points because it's very detailed on the input thingy.
Two string, or do you
Oh,
know?
that
No,
one.
when you input your thing and then it's like very specific.
The
Okay.
14 point, right?
Yeah.
Yeah.
Oh, I
didn't
must
get
have been
the-
off by like a teeny bit.
Yeah, like 0.00001, something like that.
Okay. Maybe I should go fix that. I don't know. Is it worth?
What?
I just don't know if it's worth going back to work on that.
Wait, how many points you get for like quest 5?
For the first 5?
No, the fifth one.
1, 2, 3, 4, 5. I got 30 instead of like 33.
Okay.
So I didn't realize I was not getting full credit. So I'll probably go look at that.
Okay.
But yeah, I guess I'll work on that later. Thanks for letting me know about that. I'm probably gonna hop off if there's no question or anything.
Right.
All right. Bye.
Richard, you say you doing Nico?
Yeah.
Like what kind of questions? Like medium, easy?
I just do mix. Usually it's best to do like 1 easy, 2 medium, and then 1 hard.
So like you already learned data structure?
Yeah. Because I did Python as well, and I finished 1 A, B, C. And then I think I finished Java too, all the way to C, which is data structures.
Like
So
you took it like here, like full
yeah. For Java I did. Java I just self did it. Yeah. But like, because my major requirements, I'm basically done with my major requirements except for my math.
What are you going to major? Computer science, right?
Oh no, I'm doing data science.
Data science. Okay. And how many classes you've taken here?
I think like 5 or 6.
Like are they all transferable to your
Yeah, they're transferable.
okay. So okay. Okay. So which means you graduate much sooner, I think. Are you in Bay Area
Yeah.
or yeah, I
Right.
mean like when do you expect to graduate?
Maybe 3rd year in 3 years.
Okay. I mean good luck.
Yeah.
All right.
But
What yeah. What kind you have
I don't know.
do you know what you want to do?
Yeah. Like probably be like a data scientist and then move up from there.
Okay, so related to machine learning stuff.
Yeah. But it's too bad that Santa Barbara doesn't allow you to do more than 3 classes first semester. No, not semester, quarter.
First semester.
Quarter. They do a quarter.
Oh. But after the first quarter, and then you can take more than 3 classes.
Yeah, you could take more than 3.
Yeah, just 1 semester.
Yeah.
Yeah. All right. I mean, yeah, if you have any questions, you can just send a Reddit message to me. Yeah. All right. Bye.
Bye.